The familiar can opener is a lever with a sharp cutting edge. The playground seesaw is just a simple lever too. It takes a lot of force to start a freight car moving, yet the railroad man can start the heaviest freight cars easily with a pinch bar, a powerful lever which turns the wheel. Tough luck, old boy. Here's a place where a lever comes in mighty handy. Let's take the simplest kind of lever, a rigid bar working on a fixed support called a fulcrum. One end of this lever is twice as long as the other. Let's put a 10-pound weight on this end, and now we'll put half as much weight on this end. 5 pounds, balance 10. If we have 25 pounds to lift, we just use a longer lever. The 5 pounds will now balance 5 times as much. Let's raise the lever in the air, change its shape a little, and we have a crank. Or we can add a second lever and have a double crank. Now the short arm moves 1/4 the distance, but we get 4 times the force. If we want continuous motion, we need more arms. Now we have levers that turn. The larger paddle wheel makes fewer turns, but it delivers more force. A paddle wheel is nothing but a never-ending series of levers. We can make the wheels stronger and lessen friction where the wheels touch each other by rounding off the edges and shaping them into teeth that will slide in and out smoothly. Now, the power flows smoothly and continuously through spinning leverage of gear wheels. Gears are made in many kinds and many sizes. Little gears, big gears, worm gears, bevel gears, and even lopsided gears. Over 100 million gears are spinning over the roads in the transmissions of our automobiles. The transmission is located right at the bottom of the gear shift lever. Let's start from scratch and put together a model of the gears that we shift in our motor car. The shaft on the left comes from the engine. The shaft on the right carries the power back to the rear wheels. To connect these two with gears, we'll need another shaft, known as a counter shaft. These two gears carry the power from the engine shaft to the counter shaft and are always connected or in mesh. This gear on the drive shaft going to the wheels is free to turn around the shaft. We'll put it in mesh with another gear on the counter shaft. These gears are always in mesh and keep turning while the engine is running. To switch from one set of gears to another, our transmission needs a short shaft like this, known as a clutch sleeve. It cannot turn on the drive shaft, but it is free to slide back and forth. On the sleeve, we'll mount a large gear, which we can shift back and forth to mesh with the small gear in the middle of the counter shaft. We are now in neutral. The gears that are always in mesh are turning over with the engine, but the shaft to the rear wheels is standing still. A 3,000-pound automobile takes a lot of force to start. So in low speed, we get the greatest leverage by letting the smallest gear on the counter shaft turn the largest gear on the drive shaft. The engine on this model is running at a constant speed of 90 revolutions a minute. With low gears in mesh, the rear wheel is turning at 30 revolutions a minute, about a third the speed of the engine, but with 3 times the force. The power is going through these gears in the transmission. After we've started the car rolling, we want fast pickup. So we shift into second by sliding the sleeve backward to mesh with this gear on the shaft to the rear wheels. The wheel is now turning at 60 revolutions a minute, and the power flows through these gears. For higher speeds, we let the power go directly to the rear wheels. We shift the sleeve forward so that it meshes with the shaft from the engine. The power travels straight from the engine to the drive shaft. Now the shaft to the wheels is turning at 90 revolutions a minute, the same speed as the engine. But here's a problem. An automobile must be able to go backward as well as forward. So we add one more set of gears to reverse the shaft to the rear wheels. With the gears shifted into reverse, the power travels through the transmission in a path like this. We now have 3 sets of spinning levers for going forward and 1 for reverse. With a gear shift lever, we can shift to any set of gears we wish. But with all these spinning levers in the transmission came noise and wear. Experts could shift gears quietly by careful timing of the gear shift and the engine speeds, but most of us made plenty of noise until new engineering developments made possible the long series of improvements that followed. When we shifted gears, we got a clash because the gears were not running at the same speed. In other words, not synchronized. So engineers set to work to develop a synchronizer. The synchronizer works like a cork twisted into the top of a bottle. The cork will turn until it is so tight that the bottle turns with it. Synchro mesh works the same way. When we shift into second or high, the synchronizer brings the gears to the same speed before they come together. The drums won't let the gears shift unless they are turning at the same speed. When the gears come together, there is no clash, and the shift is made quietly and easily. In the transmission of the up-to-date automobile, we have a powerful low gear to give us a strong spinning leverage in starting. A fast-turning motor must set the weight of the car in motion. In second speed, we can change leverage to get going fast at the same engine speed. With the leverage of third gear, power goes directly to the rear wheels, and we can go as fast as we want. Now, every driver can shift gears at any time, regardless of speed. Here is a hill that will give us a real chance to see how smoothly and reliably our spinning levers work in our automobile transmission. This driver is going to let her car gain a speed of 60 miles an hour down the hill. Then she will shift into second speed and bring her car easily and safely under control before it reaches the bottom of the hill. A thrill a minute, neck twisters, spine shakers. Rides like this are a lot of fun once in a while and for some people. But few of us would like to do very much traveling over the waves of a roller coaster. These are only a few of the devices that man has invented to give himself a thrill and a pain in the neck. Sudden ups and downs are all right in an amusement device, but automobiles haven't much use for them. The automobile engineers know that in our motor cars, we want comfort and a smooth, level ride. Even when we want to travel on the level, the ups and downs, the waves in the Earth's surface, complicate the problem of getting a smooth, comfortable ride. The bumps and dips in the Earth's surface over which we travel have been reduced. Great progress has been made in leveling and smoothing out roads and highways. But automotive engineers have long known that all roads can never be made perfectly smooth. Even the smooth, paved roads have long, gradual waves, or small, sharp bumps that have different effects at different speeds. The wheels of our motor cars follow these waves, moving up and down with each change in the surface of the road. So, to give us the smooth, level ride we want, engineers knew that the smoothing and leveling would have to be done by the motor car itself. Between the moving wheels and the passengers, some sort of a bump leveling device is needed. Let's see for ourselves the method by which the engineers have approached and solved this problem. Here is a wheel, fastened so that it is free to move up and down. The wheel rolls on a moving belt, rising and falling whenever it strikes a bump. A platform, fastened solidly to the wheel, carries a tracing pen, and when the wheel moves up and down, the tracing pen draws a line which shows the movement of the platform. To get a true picture of the up and down movements, the tracing paper moves at the same speed as the moving ground belt. We'll start the model running. Now, the traced line gives us an exact picture of the up and down movements of the wheel and platform. Let's see what happens when we use more speed. At high speeds, the effect of a bump is considerably greater. In slow motion photography, we can see that the wheel climbs the bump and bounces into the air. Of course, this jolting is passed on to the platform. We can mount a fairly stiff spring underneath the platform to see how it will affect the jolting. Now, let's watch it in slow motion photography. The traced line shows that we have cut down the jolting because the spring absorbs some of the effect of the bump. Let's substitute a soft spring for the stiff spring that we have been using. A softer spring gives a smoother line because a soft spring is able to spread out the effect of the bump and act as a better cushion against the jolt of the wheel. But when there are 4 wheels mounted in 2 sets, front and rear, as in the motor car, the problem is complicated. Until recently, the front springs of the automobile had to be stiff to keep the axle and front wheels in line. If one set of springs is stiffer than the other set, the stiff set will bounce harder and faster. We can see that this unequal springing, stiff springs in front and soft springs in rear, causes pitching when the wheels strike a bump. The traced line shows this clearly. The only way to eliminate this unequal springing and make the front springs soft is to give them only one job to perform, the job of absorbing bumps. Suppose we replace the bouncing axle with a rigid, immovable beam. Now the wheels can be fastened to the beam by 2 parallel swinging arms. The wheel is pivoted so that even when the arms are tilted by a jolt or bump, the wheel remains vertical and in perfect alignment. And so now, in place of a stiff spring, we can use a soft spiral spring to absorb the jolts and level out the bumps. Since the rigid beam and the swinging arms keep the front wheels in line, there is only one job left for our springs to do. With both front and rear springs equally soft, the platform is held in balance. But now that the front and rear springs are soft, we have another problem. Springs that are soft enough to level out the bumps will compress too rapidly under a heavy shock. And springs that are soft enough to absorb small shocks have a tendency to continue bouncing after they have been compressed or stretched. So to help the springs absorb heavy shocks, we can slow down their action by means of shock absorbers. The shock absorber acts like a brake in delaying the movement of the spring, and it prevents bouncing when the spring is compressed and then released. We can make the severest kind of test to see whether we have a method that will really iron out the ups and downs. We'll use a lot more bumps of different sizes, and we'll run them under our wheels at full speed. Now watch the traced line. The traced line seems to be pretty smooth. Let's watch through the slow motion camera and see just what's happening. No more pitching, and the soft springs with their shock absorbers spread out the effect of any bumps that they can't completely absorb. Of course, in actual practice, where strength and safety are of maximum importance, engineers have made use of these same bump-absorbing, road-leveling principles with a much stronger and more durable construction. The front wheel is pivoted so that it can be steered in any direction and is mounted on a strong, upright arm. The upright arm is fastened to the rigid, immovable crossbeam by means of two parallel swinging arms. The swinging arms and the rigid crossbeam do all the work of keeping the wheels in perfect alignment. So the genuine soft knee action spring has only one job to do: cushion the bumps. A double action shock absorber controls both the compressing and stretching of the spring as it absorbs heavy jolts. This combination of soft cushioning springs, together with positive double action control on the front wheels, is balanced at the rear wheels by equally soft springs with the same type of double action shock absorbers for control. With soft, balanced springing, held under positive double control, the smoothing and leveling of roads is done by the motor car itself. The pitching and the ups and downs are eliminated. Here is a real test on a full-size scale. That pipe sticking up from the top of the car is a giant tracing pen. The sky itself will be our moving strip of tracing paper. And this tank of skywriting smoke will take the place of ink. The car rides smoothly over the waves, while the wheels do all of the pounding. Watch the traced line. And so, the pain in the neck has been taken out of ordinary driving, giving a truly level ride over any bumps on city streets or on country roads.
Not bad. We still make suspension like that nowadays, guys. We still do it. Suspension's still made with that's double wishbone suspension. Still do that. Hi, by the way. Oh boy. That's right, Max. NASCAR's double wishbone as well. F1 still has double wishbone? Yeah, they do. I know, Pigsy. I know, it's nice. I told you I was getting rid of it. I was inhaling too much beard hair, man. Screw that. There are those chops. Oh, yeah. Yeah. That's all I had time for. Did you choose this because of last Friday? What? Or something like that. F1 doesn't have torsion bar. No. F1 has what's called a transverse spring. So in that video, they were talking about double action suspension. F1 cars they don't have this. They have that. See that? Well, it's not exactly like that. The upper control arm has an eccentric on it, and that eccentric is pushing on this spring, or the spring, I should say. The spring, and then this lifter right here is pushing on that eccentric, and that wants the control arm to go up. That's a little different than torsion. Remo approves of this? No, not really. Oh, look out, man. Yep. So, yeah, I mean, double wishbone, guys, what they were talking about here, cars still use this. Oh, yeah, still use double wishbone. Yeah. Cool thing to note about this. All right. They want the tire to keep moving straight up and down. You don't want the tire to do this. So note the length of your control arm here and your control arm up there. Two different lengths to make sure that when this thing rotates, the tire goes up and down perfectly. Oh, nice, Ren. That's good. Yeah, no, okay. You have two different radius. Your two different radii for each arm. Still, yep, nope, still do that with suspension. Oh, yeah. But does it have spokes? Yeah, and we need more spokes. There's a few trucks out there that still use torsion bar springs. It's a standard type challenge good if you want to put four-wheel drive in it. Torsion bars are good. I'm more of a fan of traction beams. Okay. I'm more of a fan of traction beams for the application for a truck. I might be a little bit on the biased side though. Traction beams, baby. Traction beams are for winners. Oh, yes. Traction beam. Yeah, I mean, trucks still have solids. Not so much up front anymore. I mean, except if it's an off-road vehicle. But yeah, cars, you still use double wishbone, guys. Yeah. And all you need is the... Yep. Yeah, traction beams. Nice. What is on your face? What year is this? 1976. Gold value. Yeah, I know, right? It's very weird. But yeah, suspension basically still works like that. There's been a couple of like innovations for that over the years, like the McPherson strut. The McPherson strut basically takes the double wishbone and simplifies it. A lot of cars use the McPherson strut now. Instead of having a lower control arm and an upper control arm, all this, instead of the upper control arm, they just have the spring attached to the upper control arm, and that's it. Do you think something like this could be used for community watching? I don't know what this is. Colonial Gunsmith? I don't know. It depends on who owns the video. Someone used beam to show gravity on different celestial bodies. Let me see. Anyway, yeah, cool thing on suspension, man. All right, let's get into space news here after we watch this. What is this video? Earth gravity. I'm good, Nazalik. Mars gravity. Okay, not bad, not bad, not bad. Nice, Wishio, that's cool. Moon gravity. Oh, okay. Pluto gravity. Car's gonna go flying. The springs are gonna shoot it off into the air. Watch this. Boink. Uranus. Oh. Yep. Saturn. It's gonna go right through it. Oh! Oh! I wonder what happens when they set it to the sun. It'll go right through. Ready? Spronk! Oh! Oh, that's funny. The sun gravity is the best. It's just like, deleted. Yo, you want, here, your car was here. Your car was here. But it has now become lumber. Oh. Good video, man. All right, let's look around and see what we can see. So, got some good news coming out of Starbase. We saw there's some pretty cool stuff to update. Also, more John Deeres are more John Deeres are just doing that. That's okay. That's a thing. Thank you, LTO. Okay. Oh, thank you, Mycon. You saw this in Boca today. What's that? What the hell? That's the... Okay. So that's a thing. Let's see. All right, let me compile the rest of the news here. Okay. Space news. Yeah, Jim, tell me when you're local. I'll Psyche gets huge solar arrays for trip to metal-rich asteroid. Very good. Nice. Curious, are you sporting mutton chops? No. No. What would make you think that? Okay. I got a couple more things. I gotta go through my likes. Yeah, here we go. Total fabrication. Wait, was that an abandoned tank? One in the mud? Don't know. The tanks are running out of gas, so they're just taking them. Tank is pretty useless if you can't move it. And before you say, oh, well, they could just fire the gun, couldn't they? No, you can't. You need power to do that. T-72s and T-90s, if I'm remembering correctly, have an auto loader. Can't manually load ammo. That's why they did that, to give the turret a smaller profile, so that the tank could hide behind hills and stuff. Yeah, you need power to fire it. Yep. Oops. So if it's out of gas, it's literally just a big piece of metal. Yeah, it's pretty useless. Why don't tanks have bigger tanks? Yes. I don't know if it's electrically primed, Signer. Knowing the Russians, it's probably not. The autoloader, though. Yeah. Yep, that's right, Arctic. You like that? Would it be the same as the Abrams? No. I can personally attest to Abrams having to manually load ammunition. Yep. I've loaded ammunition. Well, duds. I've loaded a dud into the breech of an Abrams. Yeah. It was a dud. But, yeah, no. It's a little ammo door behind you. Right? So you turn. You open up the ammo door. It's a blast door. Pull the cartridge out. Put it on your knee, pivot it around, and put it right in the breech. It's pretty neat. I'm a big fan. You wanted to try. You want to do this, Arctic? You can't do this until you make sure. You got to make sure that it's all. You got to make sure that it comes in right, or else it's gonna look patchy and weird. See me, you know, when you get up to my age, then it's all right. You can get that done. But yeah, no, I couldn't do it for the longest time, man. Now I can, though. It's nice. Yep. So, all right. What else do we have? Okay. I'm just gonna queue up the Starship stuff. There's, once again, there ain't much going around. There's the Psyche stuff. So Psyche got its solar panels installed. Psyche is a mission that SpaceX is gonna launch out to the Psyche asteroid. That's pretty cool. We had some pretty cool deliveries to Boca, and then yeah, they're getting all kinds of parts up in there. And then, yeah, there's the Starship update. We got a couple of Starship videos to go over. So, did you cover this? Post-launch investigation. Oh, the Astra launch investigation. No, I haven't. I'll tee that in there. I didn't get the full update. Hey, Biggie, 42-month resub. A little more space, okay? I have that one already. The first one. What about the second one? Nice. Okay. So, guys, you know, I know I'm not gonna be covering so much the rhetoric that's going on between the head of Roscosmos, Dmitry Rogozin, and everyone else. He's getting into Twitter spats with people. Scott Kelly said he should be working at McDonald's, which is kind of funny. And then Dimitri replied to him, "You need your head examined or something." Yeah. Give me 1 second. All right. Here's my favorite astronaut now. Dude, Scott Kelly's from Jersey, Kem. He's from the northeast part of the U.S., like the kind of the part of the U.S. that I'm from. Jersey is not Massachusetts, though. Those are two way different things, but it's the same region. People in the northeast speak their mind very candidly. Yeah, they speak their mind very candidly. So Scott gives no fricks. Yeah, no fricks.
Discovery, go at throttle up.
Hey, Jam, 84 months. Thanks, man. Yeah, Kim. They're very candid about things. Yeah. So yeah, I don't really want to cover too much of that, but guys, this is just too juicy to not cover. And no, it has nothing to do with what's going on. It has nothing to do with what's going on around, like with Roscosmos and stuff. But here, let me show you. Wait, hold on. What? Okay. Chem Savage. Wow. All right. Scott's, yeah, like I said, very candid. What the hell, man? Oh my God, what is happening? I don't understand. All right, check this out. So, there was a person in Russia that saw this on the Beltway The beltway around Moscow, it's upside down. And it is a Buran orbiter. It's one of the, it was spotted on Sunday per Katium. No, nice. Several followers sent me a link to an article that said it was Buran hull transported by trucks. It was spotted near Moscow this Saturday. Looks like this is Buran 2.01. Looks like that is 2.01. It was moved from Zhukovsky to Zadorozhny Museum of Technics. Now, oh, a museum. All right, what's this? I don't know what this is. Private museums. Well, no, it still works. All right. So it's a private museum. All right, cool. A technical museum. What does he have? Hey, nice. All right. Dude, a Chaika. 2 Chaikas. 3. How many Chaikas you have in here anyhow? Look at all of them. All right. Jeez. Oh. Well then. Is it even strapped down? I don't think it needs to. It's just heavy, but wow. Whoa. Damn. Okay. Wait. What's that down the end? Oh. Cool. Wow. So I guess that museum acquired that Buran. So, alright, so this Buran is not the one that everybody visits. That's not the one that's in the abandoned hangar in Baikonur. They had said that they wanted that back, but I don't know. Maybe they'll just take it. Who knows? That one was over here. Here, Zhukovsky. It was here. I think it's right there. See? That's that one. That's 2.01. It's with a bunch of other planes that are just kind of sitting there. I'm not sure what those are doing, but whatever. Yeah, there's like a Berkut there. There's a bunch of Su-27s. MiG-29s. An M4 right there. That's pretty cool. A bunch of stuff. There's all kinds of weird stuff in this airport. Oh, can I have one? Can I just take one? Maybe I could go find one. That's a shame. That's just a shame. That's even more of a shame. What the hell? Soon they will need to fly museum pieces. Hey, someone's gonna need to document all of it. So I mean, we want some of those. We should acquire some of those. It's better junk than operational. I mean, the Tu-144 is kind of a piece of junk, dude. Turns out that making something go faster than the speed of sound that big induces a lot of stress on things that you didn't anticipate for. Regarding the video from the owner, by downloading from the owner, that's using how to use it such a non-commercial personal education fair use. Yeah, Jack, I'm gonna say that's a no. Oh, yo, that thing is there. Oh, the VMT is there too. Can I have that? I just kind of want that. That's Energia LOX tank right there, fellas. Yeah, Energia LOX tank. That's a rocket part right there. I'll just take one, thank you very much. Kim, we'll go get a tractor. We'll take it. They won't miss it. It'll be fine. No. Anyway, jokes aside, they did move this Buran somewhere. They moved it to the museum. Hopefully they restore it. That'd be really nice. Zhukovsky is the place. The MAKS air shows took place and many prototypes were tested. It's the airport for CAGI Institute of Aerodynamics. Also, the MiG 1.44 should be there. Yeah, a lot of history at that airport in Medco. I saw a lot of, dude. There's some pretty legendary planes from history there. You know, modern conflict notwithstanding, like there's a lot of stuff there. Let's go peep again. That's Zhukovsky Airport. So there's an aerodynamics institute there too. But man, the VMT Atlantis there, that's what they used to move the Energia core stage around. They flew it. I'm not sure what all these are. They look like 757s, but it's probably not 757s. I mean, they might be. I don't know. That's the Tupolev 144 supersonic transporter. What else we have? A bunch of IL-76s, IL-78s. An IL-96. Wow, that's not an old plane.
Discovery, go at throttle up.
Tier 284 from Yarg. Speaking of going fast, how's it been 8 years already? Also, did your beard go through partial re-entry? Yep. Suborbital trajectory. The Tu-144 at that airport was used by NASA as a flying lab. I bet it's a Tu-204. It's similar to a 757. There's a couple of 160s right there. There's a Tu-95. That's just a shame. The 160 and the 95. That's just a shame. I want them. That's why it's a shame, because I want it. Bunch of Sukhoi 27s there. There's a Berkut over here, the reverse swept wing. There's a plane that looks like an F-111, but it's not an F-111. It looks like it though. That's not an F-111. I think it's like an Su-25 or something, or Su-24 or something like that. Bunch of MiG-31s from what I can tell there. MiG-23. Yeah. There's a bunch of stuff in here. There's a, what is that, an Mi-6? Mi-26s? Nemedco, what do they do with all this stuff? Are these just test prototypes? Because they're freaking everywhere. 24, 25. Yeah, the frog. Yeah, we call it a frog foot over here. That doesn't look like that. It doesn't have the swing-a-wing-a-ling-a-lings. What's the dark blue? That's a MiG-29. That's a demonstration squadron MiG. So, like they're Blue Angels, basically? Or Thunderbirds, take your pick. I don't see any Su-25s. Oh, nope, there they are. There's two Su-25s right there. I mean, look at some of these planes still have old registrations on them. Is that an Antonov 124 by the Buran? No. IL-76 or 78, I can't tell. There's another M4 right there. S-Dos, what's that? What are those marks for? Where am I going? Oh, there's the... You linked Technic Museum Spire? No, is this Sinsheim? It's one or the other. This is a great museum. I've never been, though. I've only read about it. Buran is in here. Yeah, one of them. Yeah, these are... Oh, man. There's so much good stuff in this museum. It's such a good museum. Yeah. You can tell from the airstrip. Yeah, they got a... Look at that. They got a 7.4 right there. That's really cool. That's a great museum. What's over here? Yeah, so... Nemedco, what do they do with... Are those planes just whatever? Like, just junk or what? Maybe it's their boneyard? I mean, I'm pretty sure it snows here, so I don't know, dude. But yeah, the Buran was moved from here. It was moved from there. There it is. And looks like a guy from a museum bought it. It's hard to tell, but it's like the scrapyard. After the test, the plane is parked there, and everybody talks about preserving it or keeping it if something changes, but there's no money to do anything. Yeah, I got you, man. Well, it looks like somebody bought that. It looks like, what was that guy's name? Vadim? Vadim Zadorozny. Looks like he took it. Somebody probably bought that before the 24th. I don't know, man. Yeah, it's kind of cool, though. Kind of cool that someone's going to do something with it. Either that or it's scrap. Yeah, I know, Sammy. Isn't it good? Yeah. Yeah. Oh. Yeah, there's a lot of... Look at all the testing articles. The Berkut's... Ah, the Berkut's just sitting there. That... Yeah, if anything, that should be in a museum. The black one. Or it could be in a boneyard. I mean, that's good too. Yeah, yeah. I love peeping on this stuff. It's fun. Yeah. Okay. There's a lot of these. Do they make these here in Medco? Is that a Yak 203 by the Berkut? A Yak? I don't know what a Yak 203 looks like. I'd have to look. Okay. Yeah, there's a 29 right there. 29. That's a 31, I think. Yeah. Couple of IL-96s. Damn, dude. All right. What's that mini shuttle type thing? That's not a mini shuttle, dude. That's why we're even peeping over here. That's Buran 2.01. It's the Mark II version. Never completed. But somebody spotted it on Moscow's Outer Beltway. It's apparently going to a museum, which is cool. Yeah. I don't know why they felt the need to transport it like that. But, you know... I'm sure that's good for it. Why does the Moscow River look black? It's deep, dude. That's why. Deep. Deep river. Water's darker if the lake is deeper or river. Where's the rest of it? I don't know. That's what it looked like before. And that's definitely the same orbiter. Stolen? It is a real orbiter. It just never flew into space. They never finished it. I want 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 it. I don't know why. I don't know why it's a piece of junk, but I want it. Anyway, so that's the news coming out of there. That's pretty neat. So the Psyche mission. Update on NASA's Psyche mission. It got the solar panels installed. The Psyche mission is a mission that's going to be launched by SpaceX, and it's a satellite that's going to go out to the asteroid Psyche, which is a supposedly, you know, you keep hearing people say like, oh, there's $1 trillion worth of derp out in the asteroids. Psyche is going to go investigate one. It's going to go to one we think is very mineral rich, which is actually really cool. Here, let's take a look. Or we could just, you know... Testing solar panel deploy. Oh, that's neat switch. Cool. Yeah, RJ, something like that. I'm not too incredibly well versed in it, but yeah, it could be. Yeah, didn't they call it like a protocore or something? When are we gonna send up old Brill to drill on an asteroid? Actually, Tessa, NASA's newest class of astronauts had an oil oil industry drilling engineer. True story. Most of them are, RJ, yeah. That's a big solar panel. Ugh. Yeah, very big. There's a new study that it doesn't have as much metal as once thought. Yeah, well, I just did a study and I disagree. I just did a study, Halsey, and I disagree. I think there's more. You know, you could study it all you want, or you could send something there and find something. I studied though. I said it's full of I said it's full of metal. I said there's oil on it. I don't give a frick about no damn study. Why don't you study this asteroid? Got him. No, it's better if we send stuff. But yeah. Who said anything about oil, man? You cooking? Got to send something out there eventually. I studied it. It has an alien civilization on it. Yeah, we should go find it. Panda Man. I don't know if that's going to happen, but they're dude, got to be another planet out there with it on it. I would be very, very, like, I'm not talking in our solar system. I'm talking, like, out there. There's got to be another planet with petroleum on it. There has to be. Like, probability says, yeah, there's got to be. There is. Titan. Yeah, it's methane. But I guess, yeah. Don't need oil, plenty of methane on Titan. Yep. So maybe we should go there. Just putting it out there. Maybe we should do that. You know, that'd be kind of cool. Maybe we should do that. Anyway, so yeah, that's what's going on with Psyche. Here. I said maybe we should go there, and that's why I wanted to segue into this. Second bay has been retracted for SLS. Third one seems to be almost retracted right there. And the crew access arm is in position for the Orion capsule. Might get attacked on Titan. Get out. Get out. Get out. Here you go. So, this is in preparation for a rollout, which should be at about, 9 days. Little under a week and a half. SLS rollout on the 17th. You don't need a time eagle for that long, Tessa. Untime him, please. Thank you. Is Artemis 1 going to have crew on it? No, unmanned on this one. Unmanned on this try. You got to validate that Orion can stay in deep space for a long period of time, and that's what they're looking to do. Two will have crew on it. And that kind of goes into a bigger thing, guys. The Artemis 3 core stage is almost fully manufactured. Not assembled, but manufactured. The Artemis 2 core stage is fully manufactured. Yeah. It's fully manufactured, and they got to just put it together. Hey, Kimmer. So, yeah. That's pretty cool. We're almost there. Almost there. Found that MiG. You were so close. Let me see. Oh, that thing. Yeah, that thing. Yeah, this guy. Yeah, Medco, that freaking thing right there. When was this thing made? February 2000. Interesting. Yeah, look at that. Look at that thing. Huh. 2000s complete with crappy 2000s graphics. All right. I mean, Medco, that's cool. I'm not gonna lie, but aesthetically, aesthetically speaking, the SU-27 and the MiG-29 are, yeah. You can't. I mean, that's cool looking, but that is arguably cooler looking. Arguably, I mean that in the 29. 29 is a great plane. I never really wanted to see it get put to the test, but also, you know, I think it's fair to say. So that plane is right there. Man, that's a biggin. Look at it next to the 29. That's a huge plane. Yeah, I know, Flight Sim. You like that? It's the canards, isn't it? Yep. Yep. They even did that with the freaking SU-27s, man. Look at that. That's aesthetic. And then they attach this garbage to it, and it looks ridiculous. It's ridiculous. Look at. Oh, that's aesthetic as frick. Guys, I have idea. Put canard on it. No! What the frick's the matter with you? What are you, drunk? Wait, don't answer that. It was tested and proven to burn really well. Well, I mean, some MiG-29s. But some. Afternoon, nice chops. Thank you. Thank you. Yeah. I have face canards? Oh my god. Oh my god. Oh my god. Not like this. Oh no. Oh no. I do though. It's funny as hell. This is actually a face splitter. Thank you very much. Because it splits. I don't know, man. Their facial chopsticks? Alright, that's fair. Oh, yeah, no, Dread. I think 23s and 25s and 31s look stupid. 29 is good. 21 is good. 17 and 19 kind of look like a tractor. But also, good plane. So dare I ask how we got on the topic of Russian fighters? No, I was just looking around that. I was looking around Zhukovsky. That's all the like flight prototypes are there, drummer. We're talking about planes. That's it. Relax. Let's see. So Astra has a post-launch investigation. Here, let's see. Let's see what Astra's up to. This one. The Digi looks nice. It looks nice. Medco. Yeah, it looks all right. So, Astra had a little bit of a problem with their last launch. I'll show you. Like, the second stage ejecting inside of an unopened fairing and then firing. Yeah, not ideal. Not ideal at all. Yeah. So, let's see. Let me read. On February 10th, we launched LV0008. This was our first launch with a deployable customer payload and our first time launching from Cape Canaveral. After a nominal first stage flight, an anomaly occurred during the stage separation process which resulted in the upper stage not reaching orbit and the end of the mission. We immediately initiated our investigation process to determine the root cause of this anomaly. Now we can share more about what we've learned to date. Our investigation verified that the payload fairing fully did not deploy prior to upper stage ignition due to an electrical issue. Payload fairing did not fully deploy to upper stage ignition due to an electrical issue. The separation mechanisms, which our fairing has 5 of, were fired in an incorrect order, which resulted in an off-nominal movement of the fairing that caused an electrical disconnection. Due to the disconnection, the last separation mechanism never reached its command to open, which prevented the fairing from separating completely before upper stage ignition. Separately, we discovered a software issue that resulted in the upper stage engine being unable to use its thrust vector control system. This led to the vehicle tumbling after the off-nominal stage separation and caused the end of the mission. What we learned: the root cause of the fairing separation was an error in an electrical harness engineering drawing. This harness was built and installed into the vehicle exactly as specified by our procedures and the engineering drawing, but the drawing error led to two harness channels being pictured below at the locations 4 and 5 being swapped. Prior to the LV0008 flight, we had conducted an end-of-the-line signal test to verify the separation system and ensure that the system was wired correctly. This test would have been able to detect an error in the harness build or installation, but it was unable to detect an error in the design. Yeah, like how spell check doesn't check for grammar. Got it. The swapped separation channels caused a different deployment sequence than we expected, and this led to the failure to open the fairing. We'd been able to recreate this failure mode by conducting several experiments at our factory with real flight hardware, One of the benefits of having an active production floor with several launch vehicles in various states of production at the same time. After determining the root cause of the software issue, we found that our flight control software was vulnerable to a specific packet loss failure mode. A missed series of signals resulted in a chain of events resulting in the upper stage inability to recover from its tumble. Although we had designed our software suite to be resilient to packet loss, an unlikely combination of factors, it always is, caused a failure that we didn't predict. We've been able to use our hardware in the loop simulator to step through exactly what happened and diagnose the root cause with high confidence. How we fixed it. Through the investigation process, we've identified two problems that need fixing: the harness issue and the software issue. Soon after discovering the harness drawing error, we fixed the drawing and incorporated the chains onto previously built harnesses. We also implemented a new end-of-the-line signal test that will allow us to identify this class of issue in the future. If it were to occur prior to launch, on the software side, we've introduced a trio of upgrades designed to make our system even more resilient to packet loss and other similar failure modes. Through constant iteration and extensive testing, we've been able to demonstrate that the changes eliminate the failure mode we saw in LV0008, while making the software suite much more robust. Here at Astra, iteration and learning are core points of our culture. It says I've been continuously impressed, but who wrote this? Chris Kemp? Oh, Andrew Griggs. Okay. Senior Director. I've been continuously impressed with the speed, passion, and diligence that the team showed as they worked through these complex issues to identify exactly what occurred and determine the right path forward to resolve each problem. With the root causes identified and corrective measures in place, we've prepared to return the launch vehicle with LV0009 soon. Stay tuned. Fellas, I got a little bit of a question. So the software thing I can understand. We had an anomaly? We'd have to clear the area? I have a question. More photos of Buran upside down. Oh, cool. I'll check that out. I'm not sure how the harness was incorrect and not spotted with various testing. Well, Dead Crew, there's that, but I'm turning through variables in my head. Give me 1 second. Okay, I gotta look at something. I gotta do some research here. Give me 1 second. And this is kind of superfluous, but it's just kind of to appease my mind, I suppose. Okay. Actually, Rocket Guy, it's kind of good that you're here. I have an industry question, if you don't mind. All right. So, Astra said that the physical wire harness deployment sequencer, right? So, like the actual physical hardware for the fairing separation sequencer was out of order. So 1, 2, 3, 4, 5. So when so 4 was at the top and 5 was at the bottom. So it was 1, 2, 3, 5, 4. So the fairing didn't open. That's what we saw. It pretty much corroborated exactly what we were thinking. The camera would have been right here facing this way, and we didn't see number 4 right there open. I may have answers. Yeah, no, I got you. They said that the root cause of the fairing not opening it wasn't hardware, it wasn't QA. Well, not so much. Like, the hardware worked as advertised, right? But they said that, this was because of an engineering drawing. Somebody got an engineering drawing wrong. Now, Rocket Guy, I have a question. I understand when you're doing iterative design that the design changes all the time. But where my mind is going with this is that, well, wait a minute. Didn't LV6, 7, and 8 all have the same fairings? And if that's the case, because they're all the same version of the same rocket, they're Rocket 3.3, right? I think, I'm pretty sure. I'm pretty sure they didn't change anything between 6, 7, and 8. Now, if that's the case, then why would the fairing sequencer be different on 8? That suggests that every single rocket, every single piece of hardware has its own drawings. And I guess that would make more sense with rapid prototyping, right? Like rapid iterative design. But if the fairing worked on 7, why would they go to 8 with a different engineering drawing? I'm confused. I guess my question is that why did they change it? Like, I'd be curious to figure out why were the drawings changed? Did somebody make a clerical error somewhere? Or did Launch Vehicle 7 have different drawings than 8 because they changed things? Because usually when a system works, when it works just fine, you don't change it. So that means they would have, if the drawings were different between 7 and 8, they would have changed something. It didn't work by luck, Shado. They said that in the fault tree analysis that it won't open, and they verified that test on the ground if you have the separation sequencer out of order. It sounds more like the drawings were left up to interpretations by the technicians. Poor ontology and semantics. Yeah, no, here, check this out. Look, the root cause of the fairing separation, which an electrical harness engineering drawing. The harness was built and installed onto the vehicle exactly as specified by our procedures and the engineering drawing, but the drawing error led to 2 harness channels being swapped. No, they specifically made it a thing to say that it was manufactured to spec, that the drawing was wrong. So now my question is, this is why would you change the drawing unless it was a mistake? They said something that it sounded like it was designed wrong, and in QA they verified it had been assembled as designed. Yeah, Yeah, Agavi, do you like that? Nah, Tessa, that doesn't make sense, because 7's fairing worked. 8's fairing didn't work. It sounded like they loaded a... It sounded like the guy loaded an outdated file or something, or some guy making the drawings messed up. Which is, yeah, that's going to suck, because you can trace fault tree right to one person. Because you don't... Engineering documents, guys, it doesn't matter if it's a building, it doesn't matter if it's an airplane, an engine, subcomponent, whatever. Anything that needs an engineer to build, you rubber stamp it with your name. That's the thing about engineering. Engineering is kind of like a certification. It's not... You don't go to school to be an engineer and just be like, yeah, I'm an engineer, I can do engineering things. No, if you're working on like an official document, like a building plan or something, you have to rubber stamp it with your name on it. And then that has to get notarized. So yeah, they could probably trace this right back to one person. Yeah. Yeah, you have to rubber stamp it. You have to put your name on it. That's why I tell people I'm not an engineer. I understand engineering, but I'm not an engineer. An engineer implies that I can rubber stamp things and be like, EJ designed this rocket. It is certified to fly. Nope. 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 Yeah, I mean, yeah, I guess not Hellfish. Hellfish said the same thing. Yes, and it moved up the screen because of chat. Back in your engineering days, I'd draw everything. Look over and stamp it. Yeah, maybe. But can you do all the maths? With enough practice, Hellfish, I could. That's what I mean about rubber stamping it. You rubber stamp your name on it. That means the math checks out. Literally, they did the math in real life. That's why, if you get an engineering degree, you have the ability to rubber stamp it because it shows that you know the math and it shows that, on paper, you know what you're doing. This bridge will be stable, maybe. Stamp. Yeah, Toto, that's how you get things like Berlin Airport happening. Yeah, when that doesn't happen. Yeah, it's kind of important. The UCF bridge. Oh my goodness, the UCF bridge, dude. Oh my god. The UCF bridge is where a bunch of engineers didn't do the math. They didn't do the math and rubber stamped it anyway, and they built the bridge and it collapsed immediately. Yep. Anyway, yeah, that's now, Rocket Guy, do you think that if he's still here, do you think that this is just teething problems, clerical error, or a bigger thing? I think this is just teething problems. You said scalability before. I agree. I think it's just scalability. As you go faster, you're more likely going to make a mistake. But even from my last, it's unclear if a drawing error means that the design was wrong versus left to interpretation. There are standards for CAD drawings, so if the drawing did have an error in its semantics, the design could be right, manufactured to spec, but the drawing could still have a flaw and an error. That's pretty much what happened. No me gusta Elden Ring, Ivan. Elden Ring is a casa de locos. The launch of Astra's LV0009 is currently net March 13th. TFRs for Kodiak. If they're turning around that fast, Thomas, I'm just going to... Somebody dotted a T and crossed an I. I'm pretty sure that's just a small thing. Yeah, that's what happens when you go fast. Guys, when you go fast, you're going to pull a Michael Bolton and screw up some mundane detail. Rocket Guy, tell him. Every time, without fail. Every time. And... that's what kind of makes SpaceX so ridiculous at what they do because, even they didn't get it right first, second, third try, or first, second, third landing, it took them some time. It's always something stupid. Always. It's so easy to to miss the small stuff with that. Simultaneously, the other thing about rocket science is that if you get wound up too much in the small details, you're never going to do anything. Scalability when you have a mass production line leads to oversights, control management issues, and such. Yeah, I think that's just a teething problem for them finding their scalable feet, I guess. So hopefully they'll be back. That's cool insight, and I appreciate the transparency, though. I really do. They got it down to a technical drawing, which is pretty awesome. If they do, I wouldn't want to work there. Yeah. Yeah. But yeah, I can't tell. You gotta be careful, man. It's almost like this stuff is difficult. Basically, SpaceX just assumed the risk of going fast and plans... Well, it's a testament to Elon as a project manager, James. Elon is a legendary project manager. He's really good at it for some reason. And I think he's good at it because he delegates work. He delegates work to people that are smarter than him, pretty much. I mean, that's how I would do it. If I was going to start a spaceflight company, I would not want to be the smartest person there. No, hell no. No. I would want to be the dumbest person there. Yeah, I would want to hire people that are way smarter than me. You know? That way you get the best thing done, but you could still get it done within the scope of what you're trying to do. My last was to a chat comment. Oh, I got it. Oh, okay. Yeah. Oh, that person will not get fired if they do. I wouldn't want... Yeah, no, guys, you don't fire... No. Yeah, exactly, Rocket Guy. If you're going to get fired over something like this, when the... Like, okay, if you work for, like, a software company and you push something to the web page and there's a 0 to 1, the page doesn't work, you know, it's like... Okay, we just got to fix it, you know, and depending on that worker's performance, you might want to can them or not if it keeps happening. But, like, with rocket science, like, if it was me, Rocket Guy, I don't know, and maybe I'm doing it right, maybe I'm doing it wrong. If we had this type of problem, I would not call anybody out by name. I would talk to them personally, be like, hey, don't do this again. We really got to make sure this is right. I would not change a thing. I would just make sure that we double check the engineering drawings and go from there. Because this is clearly a breakdown in communication between the guy that engineered the thing, the guy that drew the thing, and the guy that built the thing. You know? Namely between the guy that engineered it and the guy that did the drawing, you know? So, yeah, no, I wouldn't fire anybody over that. That's an honest mistake. That's not, you know, that doesn't mean your employees don't care. Like, yeah, if you fired somebody over that, yeah, I wouldn't want to work at that company either. I agree, Joey. I would use that as an opportunity to learn, and I would use that as an opportunity to... I brainstorm with my employees a better control system. Just like when we're trying to fix problems with our rockets in Kerbal and chat. I'm not going to come up with the best idea. You guys, I mean, but having more heads thinking about the problem makes... Yeah, no, that makes it better, you know? And in the case between, like, you and me and engineering a rocket... Making it better means better content for you, you know? So it's not just you guys giving me better ideas for rockets, you know? Oh, so these are distracting, aren't they? Yep. Yeah, I think Astra will be fine. I said that right after the error, that this is a small problem. I know it's a small problem. And they found errors in their software for the second stage. So, you know... That's good. That's good. They used it as a learning opportunity. They did a good fault tree analysis. They figured out the problems, and then it exposed more problems. This is what I mean about teething problems with rockets. This stuff happens. It happens, man. Yeah, no, this happens. I would give Astra the benefit of the doubt. I gave them the benefit of the doubt after their rocket went sideways off the pad. They'll get it. Not me sitting here obsessing over Dream Chaser all day. How goes it? You're obsessing over Dream Chaser? Why? Did they post new pictures of Tenacity or something? And they recreated the problems to confirm. Yeah, Rocket Guy, that shows initiative. That's what, like, full disclosure, guys, after LV008 failed, Astra's stock tanked, and I bought it. I bought Astra stock. I did. No, this is not financial advice. Because I knew they would come back. I'm confident in that company. I really am. Look, Rockets is tough, man. They're tough. They're tough because you could do everything right, and it comes down to just an engineering drawing being flipped, two things being flipped on an engineering drawing because a guy was overworked or something, or a guy just made a mistake. Maybe he was doing the drawing and somebody said, "Hey, you got those TPS reports?" and he just flipped the numbers. That's something small. It's a very small thing. That's a really easy thing to fix. No, I just keep finding more and more stuff about it, getting excited because spaceplane go burr. Yep. Yeah, no, I'm confident in their company. I think that Astra has the right model for doing small sat stuff. Their rocket is absurdly simple. Now, once again, an important thing to understand. An important thing to understand about Astra, okay? The rocket is absurdly simple, right? Here is a picture of it. The rocket is absurdly simple. It's not like stir-welded aluminum, or at least I don't think it is. The fairing is just sheet metal. It's just sheet metal with a truss structure underneath it. Look at it. It looks like a bunch of pie slices. The fairing is as simple as you could possibly make it. The upper stage is literally just two spherical pressure vessels with an engine duct taped to the back and a payload adapter duct taped to the front. Not duct tape, it's bolted, but this is all real off-the-shelf stuff. It's supposed to be low cost. That's the idea. This is very, very, very low buck stuff. Now, here's the thing. Just because it's low buck does not mean A, that it was simple to engineer, and B, well, actually, yeah, pretty much just there's no B. Forget B. Screw B. All right? Just because it's using off-the-shelf components and it's using stuff that's really easy to manufacture the rocket doesn't mean it wasn't difficult to engineer. Soyuz uses very, 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 very... Soyuz is not even stir-welded. It's just a guy with a MIG welder putting that thing together. Very, very easy to put together. Does that mean that Sergei Korolev didn't bust his tailpipe freaking trying to get that thing built? No way. He worked hard on that design. That's why it works so well. Thanks, Metroid. Another example that I use is that, first of all, I don't give a frick if you judge me what type of phone I use. I don't really care. So stow the phone talk. Like, okay, iPhones have very, very simple interfaces. Does that mean that interface was simple to engineer? No. It's harder to engineer something simple than it is to engineer something more complicated, right? And, one could argue that the over-engineering for that UI is dumbed down, and that's why people, that's why iPhone versus Android. I get it. Shut up. I don't care. It's a phone. Okay? It's a phone. I don't care. But the point is that just because something was simple to build and was built to build doesn't mean that it was simple to design. And that's why I think Astra is making this more challenging than it needs to be. But the risk versus reward is a lot higher when you try to do it this way because Astra can build a lot of rockets. They can mass produce faster than anyone. Can you give you crap for how old it is, though? I don't really care, Yarg. It's a phone. It does what I need it to do. Yeah, exactly. Yeah, I don't want your damn lemons. What the heck am I supposed to do with these? So... yeah, I mean, I think they're going to go... I think they'll be fine. I'm holding my Astra stock because... if I liked my phone like I like my vehicles, J-Speed, I would have a Tesla. I don't have Teslas. I have the opposite of Teslas. It's funny, because when it comes to phones, I don't really care. But when it comes to cars, if we're, assigning phone logic to how I like cars... Android is over here and iPhone is over here. I'm about as far this way as possible, which is weird. I don't know. I don't care about that. It's just a phone, But the car actually, I mean, I suppose one could make the argument that you need a smartphone to survive today, but you absolutely need a car. Well, it depends. Europeans are going, no, we do not need a car. What's wrong with you? We do not need a car. I mean, we need the phone. Which probably explains why people like phones more than cars over there. No, I'm just kidding. 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 My new book on sweeping generalizations is coming out next week. Look at the sideburns. Yeah? Yeah? I don't want to. Look at it. Look at it. Anyway. But anyway, I think Astra will be fine. They'll get it. They'll get it. They will. A generalization, but an accurate one. Haven't seen a car from the inside in the last month. Well, I mean, since we're on the subject, I fixed the ignition system in the truck. Do you want to see? Do you want to see? I can show you. Quick truck detour. Oh yeah, I gotta do that. Hang on. Look. Yeah. All right. So see, truck's nice, right? Watch. I did all this work just so we could do this. Wait for it. That buzzing? No, I'm fixing the buzzer. I hate it. I need the bing bong noise because the buzzer sucks. I hate that noise. It's about as annoying as the video. It's about as annoying as the video comes across as. Yep. Yeah. See? I rebuilt the steering column and man, it doesn't look like much. It doesn't look like much, man, but crows. That's so nice. Yeah, it's because the cowl for the steering column is for an automatic. I ripped it out of the junkyard, so oops. Floor it? No, I'm good. Oh my, just passing. Those are some mighty mutton chops you have going there. Danke schön. Yeah, he's good, yeah? Yeah. What's up, Crex? Hey, Whitney. Yeah, no, the buzz is horrible. You can replace it, though. You can replace the buzzer with a bong, 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 which is exactly what I'm going to do because that buzzer is annoying. It's annoying as the video is. But yeah, she working.
Discovery, go at throttle.
Yeah, that's the hole for the shifter for the automatic. I don't have that, though, so... Yeah, I mean, it works, but... Can you just remove it? Yeah, I could unplug it, Yard. Sure, of course. But I want the bong bong noise. Bong 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 bong. That's much nicer on the ears than you know. A86 overspeed bell is better. I'd have to go modify the harness to do that. I don't feel like doing that right now. Annoying. Yeah, it's supposed to be annoying for what it's worth. But yeah, the key actuator, the steering column, everything works. So yeah, my truck actually uses keys now. I went in and removed all the hot wiring that I did to get it to run. I drove that truck across the country with a hot wired ignition system. Whoops. Yeah, you have rule flackets. Oh, yeah. Yeah. Nice. You like it, Whitney? It's so stupid. No, Whitney, you really want to know? All right, so when you have a beard, right? What happens sometimes is that hair falls out of it. Hair falls out. That happens, right? And sometimes it happens when you're inhaling, and then you just inhale some hair. That's good. Yeah, very annoying. Very annoying. Yeah. So I was just on break, right? I took a break a second ago before Space News, and I'm just like, you know what? All right, that's enough. Whatever. I don't have enough time to finish the rest. Yeah, so yeah, that's why we're rolling with this right now, just for now. Yeah, so it was a real pain in the butt. Yeah, who knew hair pain in the butt? Yeah. Not up here. That's going. Yeah, I don't need to worry about that. That just falls out. Down here though, pain. So, yep. I just got rid of it. I was like, yeah, I'm done with that. So now I got the Wolverine thing going here. But yeah. If you were a top hat, you would fit right into Victorian Britain. I say, Johnny, old boy. Keep it. Primo's gonna love it. No, I don't think so. Oh, of course, Jordis. Yeah, everyone does that. Anyway. Yeah, Fractal, I'm not sure she was really into it. I mean, it's a look, I guess. It's a look, I guess. I mean, it doesn't look bad. I'm not sure I like it, though. It's a mistake. But anyway, yeah, so, fellas, the reason why I even bother telling you guys about the truck stuff is because that's the truck I want to drive down to launches soon, if there's fuel. Yeah, that's the truck I want to drive down to launches, do more Route 154s. I mean, that's kind of the reason why I bought that truck in the first place. I mean, there's also the whole, engagement thing, but two birds with one stone, Yeah, so I've been fixing it, and I'm trying to get, I've been just trying to get the truck back to stock. Yeah, Soapbox, I'm kind of with you on that one. Also, yeah, no, it's nice. Yeah, it's good, Tessa. You need a monocle. Oh, yes, old boy. You just need a top hat, and it's time to establish a republic. Republic? Oh. No. Wouldn't the right way to say it would be like, no, it's time to take over the entire world through nefarious means. Yes. Scotland, you're part of a kingdom, aren't you? No, mate, I'm not really. Yeah, you're part of a kingdom now. Taxes, please. Accurate? No, yes? "1776 called him, want you God. Further the aristocracy. Yeah. Indubitably, old lad. Well done, good job, but sorry, old boy. Everything you've come back to has changed." I don't know, Steinert, maybe. Anyway, so yeah, that's what's going on with the truck. I got the ignition system working, so I don't have to so I could just take a key instead of having to rewire the thing every time I start it up. Yeah, that was getting old. That was getting old real quick. But yeah, other than that, truck drives really good. I think I might have a pinhole coolant leak because every time I open the hood, I smell coolant, which is not what you want. But yeah, it's fine. We'll figure it out.
Discovery, go at throttle up.
Hey, Matherose. Welcome to Mission Control. You go at throttle up. Or is it just Math 3 rows? Or is it Matherose? Or is it Matherose? Either way, thank you for the sub. I do appreciate it. That's a tier 1 sub, too. Thank you very much. Probably time for new coolant and heater hoses. Yeah, Signer, God knows when the water pump was done on that thing. If it ever was. Also, just to be sure, I bought another Motorcraft starter solenoid, so the starter relay, and I replaced it, just to be sure. Yeah, the one that I took off was factory, and it still works. 175,000 miles. Still works. I have another one just to be sure now. That could be the cap, too. Nice, Lemmy. Yep. Ace of spades. It's expensive to drive, right? I mean, Sawyer, honestly, no. You know, fuel prices are not fun right now. You don't need to tell me. It's bad for everybody, right? Like, I get it. I understand that. But see, the thing is that doesn't really affect me too much. I just drive on the weekends. So, honestly, every car that I have has a V8 in it. I haven't filled up with gas in weeks. Because I don't drive. I mean, it's not like I have to commute to work. I drive for fun. So, yeah. Tough Enough has a full tank of gas. I filled up that truck. I filled up that truck probably once. Yeah. Oh, no, twice. I filled it up right when I got back from Route 154. And then I filled it up again probably about a month ago. Yeah. Still got a full tank of gas in it. I mean, go look at the footage. Seriously. She got a full tank of gas, man. I don't fill up. I really don't. Let's see. Yeah, see? Well, 3/4 of a tank. Still good. So what's new with Starship? I'm getting to it. Yeah. Also, yeah, I gotta find a better cowl. Sawyer, we gotta find a blank cowl. But is that gas orange and muddy? No, we cleaned out the tank and the fuel pump, remember? I know, Isaac, isn't it dope? It's pretty dope. Hey, Capybara, what's up? Yeah, Cantab, that's like $7 a gallon. Yeah, that's terrible. No, we don't need to sit here and whine about gas prices, guys. Everybody's on the same page there. Everybody's on the same page there, I think. But, you know, yeah, I thought you guys would want to see that. I rebuilt the ignition system, or the ignition actuator system inside of the steering column on the truck, which is cool. You should try to find an instrument panel with a tack. You can find them on eBay, Hellfish, for, I don't know, I think it's like 50 to $80, depending. I can get the tack, but you need the backing plate. So it's a universal harness to the backing plate, but there's two different types of configurations for the dashboard on those trucks. One is for the tack and the other one isn't, you know. And there's also configurations for automatic or manual, right? So I need a manual tack backing plate. It's a white bracket that goes behind it that has the necessary hookups, but it's a universal harness. So it's a universal harness into the back of the white backing plate, and then you can literally switch and swap out gauges and it'll work just fine. Also, starter solenoid stuck on isn't fun. Ask me how I know. Sawyer, I thought the reason why I replaced the starter relay is because I thought that we may have had a bad one, and I didn't. I tested it, but I didn't have my voltmeter with me. I forgot it, so I was just like, the auto store was closer than my house, and they're $20, so I just went and bought it. Now I have two, just in case one breaks. Hey, Jonas, what's up? Guy would send you a cold start video of my dad's truck, but we need to put plugs in it and new wires. I pulled the metal part out of 2 wires, but I just put the new fuel filter in. Right on. Hey, JT, 59-month resub. So yeah, that's what's going on with the truck, guys. Yeah, the ignition system is pretty cherry, dude. Everything works. I took that whole column apart. I did it off stream because I wanted to get it done. I took it apart, reshimmed the thing, replaced the bearings just to be sure. The bearings in that thing can go, and when they go, the wheel goes thunk 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 thunk. Big pain in the butt. So I replaced them anyway. I mean, the old ones are still good. So I don't know. Maybe I'll use them for something else. And then I put a new ignition actuator in. I greased the ignition actuator up, and then put the gear in, and then put the new barrel in. Yeah, it was just a lot of tedium work. Wouldn't make the best thing for the stream. So Lightning Dash. Well, I had one working on the truck, Yarg. My house was the voltmeter was at my house. I couldn't test it. I couldn't test it for connectivity. The voltmeter was all the way at my house. And the truck is a little ways away from my house. And I had some other things to do, so the auto store was closer, so I just went and bought another one. Now I have 2. Hey, Math, I don't know what time it is at your place, but at mine it's 11:45 and I'm tired. Love to all. Happy to have discovered you thanks to Whitney. Math, Whitney's cool. Whitney is cool. She's cool. My French counterpart, doing STEM stuff for the France, for the people of Français. Yeah, no, Whitney's awesome. But yeah, it's 5:45 in the afternoon here. 5:45 p.m. I'm about 6 hours behind you. I'm on the east coast of the United States. So about as close to Europe as you can possibly be and live in the United States. Thank you so much. You're cool too. I mean, I know I am because, right? Because of these. I know. I'm just... Merci beaucoup, Whitney. Thank you very much. All right. I've been catching up with the streams that you've been uploading to YouTube as I can't watch live much anymore. Hey, no problem, JT. It's all good. Yeah, shameless plug, guys, I have a YouTube VOD channel that automatically uploads cut-up VODs. Yeah, Drummer found a way to pretty much automate that whole thing so we can upload in segments. Yeah, it's really cool. Automatically. It's pretty sweet. Yeah, we don't need an editor. We have software engineers. We don't need editors. We don't need no stinking editors. Hey, no problem, Phil. So close and yet so far. Yeah, about 5,000 kilometers, man. Between 5 and 6,000. Yeah, it's only a 6-hour flight. It's fine. It's fine. 6-hour flight. Automagically. Yeah, that's right. Speaking of, so yeah, no, you guys want to go over there and hit the sub on that YouTube channel. Like, you know how I feel with, like, self-plugging, but hit the sub on that YouTube VOD channel. Do it so we can make money off of it. Yeah, no, that's the reason. I'm not, dude, straight up. Yeah, increased revenue streams. And also so you guys can conveniently look at the VODs. Because, let's be real, the Twitch playback is kind of... You know? I don't give a frick. You can hit the bell or whatever, like and subscribe. Sub to the channel so I can make money off of it. I'm not even kidding. You don't have to hit the bell or anything. I don't care. I'm not playing those stupid games. Hey, yeah, well, Max, we're just gonna double load the VODs. So you want the Twitch VODs, you got it. You want the YouTube VODs, whatever. Wait, you guys are getting paid? Twitch playback still has one advantage. It remembers the position. Yep. Mm-hmm. Get this guy some money. He couldn't even afford a full shave. Yeah, I know, right? Look at this. Look at this. This is Slam that button if you want to see more content like this. In the words of Dank, please leave a like and subscribe because it really helps me in the algorithm. Seems that Haas is a new top candidate for the seat, Magnussen. I think they should put Fittipaldi in there, but Magnussen's cool too. I'm morphing into Wolverine. We're at 850. We need 1,000 to monetize. Yeah. Yeah, there you go, Yarg. Whatever floats your boat. So you could think you're making a joke, but if you sub that YouTube channel, I'm the one that gets all the money. Remember that part? Remember that part? Sorry. Remember that part? There's a T at the end of that word. I like the transparency. Yeah. All the sense. Yep. Please sub. I need new trimmers. Yeah, I broke mine trying to get through this jungle right here. Yeah, no. Hopefully, we tap into YouTube a little bit. We can, do more fun stuff. I understand your criticism with the please. Yeah, Hellfish, if I do it jokingly, I think it's better. Yeah, because Twitch is my number one. The YouTube stuff is beer money. And I need a lot of White Claw, man. Just saying. It's not beer, but you get the idea. Fresh space news. Introducing our highest and efficient lightweight solar cell, the IMM Beta. Okay, let's see. Let's see what we got. Okay, drummer. Developed by Solarotech. Oh, God, it's the Scaleri brothers. The IMMV is 40% lighter than the typical science-grade solar cell and delivers the highest efficiency of any commercial-grade space cell globally. Oh, that's pretty neat. Well, that's pretty neat. So, one thing before we get into the Star Trek thing. Here, guys, more space. Yeah, no, Swishio, yep. That's the third time you posted those. I have them 3 times over now. Yeah, no, it's good. Yeah, great. I said Star Trek thing. Starship, sorry. Star Trek is good too. But yeah, no Star Trek news, I don't think. Here, check this out. Take a look. So there's this game that I didn't hear about until today. No, not paid for this. There's F1 Manager 2022. You know, I'm somewhat of a team principal myself. Huh. You didn't know about F1 Manager? No, I just told you it's the first time I'm hearing about it for my health. We need a hospital. A hospital? What is it? It's a place where sick people go to get better, but that's not important right now. I don't know, Alex. I want to try playing that game, dude. That would be fun. That sounds fun. It's from... Oh, Frontier's doing it. All right. Cool. Yeah. Shirley, you can't be serious. I am serious. And don't call me Shirley. Are you thinking of Christian Bale? That's Willem Dafoe. It's not Christian Bale. They kind of look similar, I guess. You know, I'm somewhat of a team principal myself. Nice 240 back there. Look at that. That's a nice 240. All right. Nice car. Nice car if you like to have meatballs. Yes, you've got to have all these Swedish meatballs. There was a firefight. Yeah. I just wanted to say good luck. We're all counting on you. GTA voice. Asked to see F1's manager. Datsun does not agree. It's Datsun here. See, nobody cares. F1 manager? No, EJ. No. That is so not right. Yeah, no. I'm just going to be doing that the entirety of that. Or we could do... Spinaldo! No! We just got to make it like every time something goes wrong, it has to be like a Renaissance painting. No! It would be awesome. It'd be really funny, actually. Yeah. We have to make sure we have a Fibonacci sequence of Italian hand movements. May I see the guitar? Huh? Christian Horner is now blaming the whole Massey situation on Merck. All right. New emote. What, like this guitar? You want to see this? I better see the table scared for its life. No, Mikey, no, Mikey, that is so not right. Play it? Why? Why do you... It's out of tune. Why do you want me to... No, I'm good. I'm good. We don't need to do that. Anyway, so yeah, F1 Manager. I'll probably give that a shot. That'll be funny. Anyway, so here's a little bit of SpaceX fleet news here. So Gav did some detective work here. One of these new SpaceX fast boat has its tracker turned on, and these boats do have names. Their names are Maverick and Goose. Did you forget how to tune or something? No, I'm too busy listening to your crying ass all the time to have some time to do it. Freaking bugs. Anyway, so yeah, we got Maverick and Goose here. Boom! Ratioed. That's pretty neat. This is in Florida, by the way. So that's pretty cool. They're little dinghies. Hey, twin outboards, though. Yo, those things probably go quick. I'll take the timeout. All right, we're good. All right, so anyway, we had some hardware delivered to Boca Chica yesterday. Austin Barnard took this one. He's the guy that was covering SpaceX, and they actually ended up hiring him to do work. So, fellas, here, check this out. What do you make of this? Yeah. That's, this is a famous, I mean, these are those are statues, obviously. No, they're mimes. This photo, but as a statue. Exactly. That's exactly what it is. That showed up at Boca Chica. I guess it's a picture of a famous photo of, I think that's the Empire State Building being made, and these are the steel workers on the Empire State Building. Don't look down. No harnesses either. They brought that down there. I'm not 100% sure why that's there. I don't know if this truck has it like affixed to it, or if they're gonna like take that steel beam and put it somewhere, but that's actually really cool. It's Rockefeller Center. Yeah, neat. Guys just eating lunch. Why do they have that in Boca? Don't know. Without harnesses. Oh, Rev, they didn't care in the 30s. 20s and the 30s, they did not care. Nope. Go up there, put the steel together. We don't really care what happens. You hurt yourself, it's your own fault. Not a good way to do things. Yeah, not a good way to do things. You kidding me? In the 30s, dude, yeah, they didn't care. Health and safety. You want to stay healthy and safety? Don't fall. Yeah, no. I'm not saying that that's okay either. That's not okay. Yeah, you don't want to do that. Oh, the guy who took that photo. Oh, even better. Oh yeah, okay. No, it's not the Empire State Building. The Empire State Building is over there. Yeah. The guy's up there. The guy's up there with business shoes. He's got nice loafers on there, and just all right. Yeah, that's how they did things, man. This guy is that a bottle of gin? What the frick? Do you think he posted that picture to Instagram before he came back down? Oh yeah, absolutely, Jim. Mm-hmm. This photo makes you anxious? Nah, it's fine. It's fine. Guys, look. These guys aren't hanging over the edge of the building, fellas. All right, look. See the wood down there? They're hanging over the wood. They're not that crazy, okay? So if you fell, it would be only about a 20-foot drop. That's just the perspective of the picture. There's definitely scaffolding below them. Yeah. Hey, no, I never said it was okay. I'm saying it's just perspective. Makes your hands sweat? Really? I mean, yeah, I guess. I'm not gonna lie to you. I wouldn't do that. No, I would want to be harnessed in. Absolutely. I don't. You could call me a bitch all day. I don't care. Excuse my language. Sorry, I did it again. Please stop. It's giving you vertigo. Really? I mean, I wouldn't. Yeah, no, I wouldn't do that. I would be a little wimp about it. Yeah, absolutely. I'll take the timeout again. Okay. What's that, Obsher? Nice, man. Hell yeah. Yeah, I mean, dude, yeah, that's how they did things, man. They didn't give a frick, dude. You think that's bad? Freaking look at how the railroads are made. Not just in the States, but pretty much anywhere. It's not. A lot of people died. One harness would be fine. One harness would be better than nothing. Double redundancy is probably good, considering, yeah, there's no respawn button. Yeah, Hoover Dam, yeah, serious. There's the, yeah, Troll, yeah. It's not just, yeah, it's just the States. It's pretty much everywhere. Trans-Siberian Railroad, the Intercontinental Railroad. Yeah, a lot of people died. Everyone falls on the first try. Yeah, so I guess this would probably be this thing is in there because it's a testament to the steel workers that built this thing. That's my guess. It's a really cool statue. It's cool that it's on the truck. I like that part at the end. That part's pretty cool. Yeah, that's pretty neat, man. Yeah, barrel, there you go. It's a traveling piece of art. Here's the art delivery for today. We'll see if these will be displayed there, if it's just passing. Oh, that's cool. Hey, all right. They, in the other picture, is only flying one flag. Now it's got the Canadians up there. That's cool. All right. Cool. That's cool. It's a cool statue. The first reply has a link to it. That's cool. That's really cool. It's a nice truck, though. 3/4 ton Dodge. It's pretty cool. Yeah, that's really neat. I like that a lot. Yeah, so for a little bit of historical context, I suppose, for that picture, guys, like, so this was like 31, 32, 1933, because that's right around when the Empire State Building was made, etc., guys. So, and this is not just the States, this was all over the world. Like, the tallest building, so, okay, they figured out steel. That's the big one. They figured out that you could use steel to make a building, and you could make a steel building a lot higher than you could with an iron building, right? That material science increase led literally, I mean, if you think about it, this is, what is that, like 1932? 1922? There's no skyscrapers. That's not a thing. We went from being able to build buildings that were like 200 feet tall, so like what is like 70 meters, 70-meter tall, to being able to build stuff that's like 200 meters tall, like that, like literally in less than a decade. So yeah, they hadn't really figured out the whole safety standard stuff yet for like building skyscrapers. But yeah, that the 20s, pretty much all over the world, like after World War I, everybody's like, yeah, we don't need to fight anymore. Yeah, that didn't last very long. Yeah, they made some crazy advances in material science, and like I said, they went from being able to make something like the Flatiron Building. The Flatiron Building is down the street. The Flatiron Building is down the street from that. It's on Broadway, right? 12th and Broadway. That is like as big as you can make an iron reinforced building. It doesn't get much taller than that. And then steel buildings made this thing look like a freaking like log cabin. Like that was it. That was it. You couldn't really make much bigger than that. I forget when this building was made. When was Flatiron made? 1902. Yeah. It's about, and that was tall. That was tall back in the day. Really tall. And then there's the Empire State Building, which was made a couple of decades later, but not much. Yeah. Yeah, see, this is looking down Broadway at the Empire State Building. It is down the street. Yeah. The Empire State Building is like 3 or 4 times taller than this building. It's freaking huge. Even for the 30s, it's really big. So yeah, like that, yeah, it was a crazy time. Buildings started popping up like weeds. And once again, I'm going to go ahead and guess that it's probably the rest of the world too. I can only really speak to like the US. I'll bet you the rest of the world was like that too. It took 15 months to build the Empire State Building. The Chrysler Building looks better. I like them both. I like Art Deco. Empire State Building. Let me see. I don't know. I don't know when that thing was made. It was the tallest building in the world from 1931 to 1970. 1970, man. Pfft. I think the Sears Tower overtook it. Oh no, World Trade Center. Damn it. Frick. When was this thing made? 31? Yeah, 31, dude. Yeah, crazy advances over that in that period of time. Like the advances in building, in making buildings and building construction were like going from like computers in 1975 to a computer in 1995 or in 2005. That's a big difference. So, yeah, I mean, they started making buildings taller and taller and taller and taller, which, once again, safety standards kind of took a second to catch up. Yeah, a B-25 hit the Empire State Building because the guy couldn't see in the fog. Crashed right into the side of it. The Empire State Building's like, all right. What's the building in Dubai made from? Steel? So, Reveral buildings nowadays, so like the Burj, what is it? The Burj Khalifa, I think is what it's called. That thing is steel with reinforced concrete. It's got a concrete, like, it's got a concrete endoskeleton that's reinforced by steel. Yeah. That's a big mother, dude. That's a big building. It's freaking huge, dude. Yeah, that's a big mother. Yeah, here, check it out. There it is compared to the Empire State Building. It's almost double the height. Grav, also the problem with my dad's truck is that it would sputter and miss at low idle after it ran for a minute, and then when my dad would floor it at max RPM, it would sputter and miss hard. Timing chain. Well, wait, no, it's a diesel. I'm not sure. Eiffel Tower is iron. Yep. Mm-hmm. I think it's iron. Yeah, I'm pretty sure. Taipei is a tall building, dude. That's a big mother. Sears Tower. CN Tower is pretty big. Yeah, the Warsaw radio mast. Yeah, that's huge. Not a lot of people know about that thing. No, it's the 5.8. Let me read again. I'm trying to talk about buildings. You're trying to talk about cars. All right. Problem with your dad's truck is it sputter and miss at low idle after it ran for a minute. And when my dad would floor it at max RPM, it would sputter and miss hard. And it could be a timing. That's something with the timing. It could be timing chain. It could be ignition timing. Get a timing light out. Time it. Get the motor up to temp. Get a timing light out. Time it. Set it to factory spec, which I forget what it is for a 5.8, 10 degrees BTDC or something like that. And then see if it works at low idle, then and if you step on the gas and it falls on its face for a second, it's timing chain. Got to replace the timing chain. It's wrought iron. Jeez, man. Do people climb the Warsaw radio mast? Yeah, sure. How does a timing light work? Oh, I guess we're shifting gears to cars here before we get to that, huh? Okay. So a timing light basically is a light that shines when you have like when an electrical signal gets sent down to number one cylinder. So I'll just use a V8 as an example because that's what I know. Right. So you have your V8 here, right? Right, so there's your V8. You have 1, 2, 3, 4, and then 5, 6, 7, and 8, right? So, down at the bottom of the V8, you have this thing, the crankshaft pulley and the harmonic balancer. I mean, it could be one or the other. It depends. There's a marker. There's a marker that's attached to the block, and then there's a marker that spins. There's a marker that spins on the balancer. So the marker would be right there on the balancer, and then there's another marker here. And now if this is your number one right there, right, your number one would have an ignition wire coming down and connecting into the spark plug, right? There's another one there, and another one there, right? And then you'd have your ignition wires go up and around or behind, depending on where your ignition distributor is. This is in an older design. Modern V8s aren't made like this. Oh, the one that Grav has that he's talking about is. So you have your ignition wire, you clip the timing light onto there, right? And then a timing light looks like basically a phaser. It looks like this, right? And then the timing light has two other wires, and you clip those to the battery, so plus and minus, so the thing gets power, right? And then this thing basically is a strobe light that flashes every time an electrical signal gets sent down the number one ignition cable. And what you do is you watch between the hash mark right here and the hash mark that's on the block. If it's before it, you're before top dead center. If it's after top dead center. And the idea is that you basically want to get the spark plug to go off right before the piston gets to the highest point of travel. So the piston is going up and down in here, right? And when it has the highest point, and then it has a low point right there. You want to fire it off right before top dead center. BTDC. Different engines like different timing. You can crank the timing to make more horsepower on the top end or make more torque on the lower end. And yeah, that's ignition timing. Very, very, very short explanation. It's a little more complicated than that. The ignition ignites only one cylinder. One at a time, Revril, yeah. Like the ignition timing on the 5.8 that I have in the 250 and the 5.0 that I have in the F100 is 1542638, but it might be different. It might be different on the F250. So you ignite different pistons at different times. 1, 5, 4, 2, 6, 3, 7, 8. Now the reason why they do that is because the piston needs to be at the top at a certain time, you know, and different pistons are up at top dead center because the pistons are doing this on a V8, right? So yeah, you need a timing light to be able to set your ignition timing. There are other ways to set ignition timing if you really know what you're doing. You can use vacuum. You can use manifold vacuum pressure to set it if you really know what you're doing. That's difficult. Just use the timing light. Timing lights are like $15 from the auto store. So like Reveral, you could anything that has what's called a distributor. So this is older engine styles with distributors. So like a Zagili, a Lada, that has a distributor in it. And you could use a timing light to time it. You need the battery and the number 1 ignition wire, and you'd be able to time it. Doesn't matter if it's a Lada. It doesn't matter if it's a 65 Mustang. Doesn't matter if it's a Porsche. They all have distributors. Would a timing light work on a rotary engine? No, I don't think so. Basically, you can overclock your engine. You can get a little more horsepower out of ignition timing, yeah, with just a stock engine if you want to crank the timing, but like that's the thing. It's not like overclocking. Overclocking, you set it, you make sure that you can keep it cool, and you kind of forget it. Now, there's really the downside to overclocking is that, once again, like on a computer, it uses more power, right? But you get the processing power, you know? With a car, and, you know, like, even if your computer's not using all the processing power of the overclocked processor, right? You're still, it's kind of like overclocking, but it's kind of not. Like, because with overclocking, you set it and forget it. With timing, you're really going to notice a difference when you're driving around on the road. You'd want to screw with the ignition timing like that if it's a race car. You really wouldn't want to do that with a road car. But there's also ways to get around it. Like, in the 50s and the 60s, the auto companies came up with something called a vacuum advance. And a vacuum advance advances the timing for you when the engine revs up. So you could set like your base timing, and the vacuum advance will advance it over time from there. And wherever your base timing is, yeah, you'll notice a difference when you're on the high end. Like, so when you're revving the engine, like if you're going fast. But yeah, the engine, you know, it's all a trade-off with engines, because it's a trade-off with overclocking too, but yeah, you're gonna see the motor is not going to be as efficient. You're not going to get good fuel economy doing something like that, which in this day and age kind of and yeah, I mean, you'll make more power, but it's a trade-off. Overclocking isn't necessarily a trade-off. With overclocking, you're going to use more power, and your computer's going to get hotter, so you have to fix the coolant system. You don't necessarily need to fix the cooling system if you advance the ignition timing on a car. The real way to get most out of changing ignition timing is also switching to a higher octane. It depends on the engine. Really, really depends on the engine. That octane is really, Synerd, to my knowledge, isn't octane more dependent on compression ratio? If you have a higher compression ratio, you're going to want to run a higher octane. Like, cars that go fast, like sports cars, take premium fuel because of the high compression ratio. Yeah, it's really and what compression ratio is basically the ratio of like, I forget what the exact ratio is. I'm sorry, guys. It's off. I wasn't expecting to talk about cars today, but I should probably know that cold. I think it's the volume that the cylinder has between the volume of the combustion chamber between bottom dead center and the volume of the combustion chamber at top dead center. I forget. More advanced can lead to detonation.
Go at throttle.
Yeah. Oh, nice. I got it right. Excellent. So a higher compression ratio, yeah, you'd probably want to put a higher octane in. But I guess, I mean, Seiner, like, that's the thing. With a lot of different engineering, it's not just x plus y equals z. You know what I mean? It's like xy cubed plus yz cubed equals z cubed to the square root of the... Like, there's multiple variables. It's not like, oh, you increase the octane just because of compression ratio. You can increase the octane with ignition timing to prevent detonation. Detonation is really bad for a motor. It's really bad for it. The reason why is because when you have detonation, you're blowing up stuff at a much higher pressure. And blowing up stuff at a much higher pressure is the reason why, like, you can't just take liquid hydrogen and put it in an internal combustion engine and have it be okay. You're going to detonate the hydrogen and the engine blows up. What's the difference between detonation and combustion? Well, combustion, basically, when the energy gets released from the result of a combustion explosion, right? The pressure wave is moving at subsonic speeds. A detonation, the pressure wave moves at transonic or into supersonic speeds. And that would be bad. That'd be really bad it's bad for rocket engines, it's bad for car engines, it's bad for jet engines. You do not want to have detonation in a combustion engine. Bad idea. Gasoline engines get overclocked in the winter when it lowers the temperature. Yeah. Yeah, I know, Revo, right? Yeah, pretty much. Yeah, exactly, Aldesert. Yeah. So, yeah, I mean, you could increase octane if you advance the timing enough, but advancing the timing enough is going to screw up other things before you have to increase the octane. It really depends. Like, the piston could, you could spark the thing way before, and yeah, then the engine would fall on its face. Then there's the rotating detonation engine. Yeah, it's a really cool idea, MotoKid. Yeah, spiral detonation, the helical rotating detonation rocket. Yeah, that'd be really cool if they can nail that. Detonation in a turbine engine is rich blowout and flame out of the engine. Yeah. Yeah, it's not good. Detonation isn't good. But simultaneously, if we made an engine that could handle the detonation, you can make an engine that performs insanely well. But the thing is that sometimes, even at high RPM, your piston going up and down, right? If your detonation wave is traveling faster than the piston is going down, yeah, that's really how engines hurt themselves. Yeah, you don't want to do that. You need subsonic combustion. Yeah, that's not good. That's not good for it. Yeah, that's really not good for it. You mean a diesel? Cough, diesel. I mean, diesels don't detonate things, guys. They auto-combust. Basically, they compress air and fuel, right? They try to take an air and fuel mixture and they try to compress it into a very small area. Like, diesel engines have extraordinarily high compression ratios. The combustion chamber on a diesel is microscopic compared to a gasoline engine. And basically what it does is it compresses that air to fuel mixture so much so it generates ridiculous amounts of heat, and that heat basically ends up combusting the diesel mixture. Diesel engines don't really detonate to my knowledge, but then again, I'm not a diesel guy. I don't really know too much about it. Yeah, too much advance causes the fuel to detonate before A, the valves are fully closed, and B, the piston is not all the way up in the bore, and the explosion tries to push the piston down while it's on its way up. That's where the knocking comes from. Oh, man, that's like your engine having a stroke. Oh, that's terrible for it.
Discovery, go at throttle up.
Tactical, 10-month resub. But yeah, good car conversation. Yeah. I had to shift gears a little bit there. Anyway, let's get to the Starship updates, dudes, and let's go from there. We have 3 videos to watch, I think. It's interesting thought. How big is the difference between a diesel compression and reentry compression? Reentry compression is way higher. You can't man, way higher. Diesel will just compress air and fuel enough to get them to auto combust. You don't get plasma building up on the inside of a diesel engine. Yeah, no, you're not moving fast enough. Dude, like the compression heating that's involved from reentry is enough to split air molecules. No, guys, it's enough to atomize them. It splits the air. Like the shuttle when it came in was going so fast that an air molecule would get stuck on the front, and 1,000 bajillion air molecules would come up behind it and squish it to the point where it rips itself to pieces. Yeah, that's what the ionizing forces are from compression heating. It's not the fact that fire is, it's not just that the air gets so ridiculously hot that it causes fire on the outside of the orbiter. The shuttle would come in, or a capsule or whatever, it would come in so fast it would literally rip atoms apart. It would split atoms, and the resulting ionization causes plasma. It makes plasma, and that plasma kind of builds up on the surfaces there. It kind of stays there because it's stuck. It's stuck between the air that's getting forced up against that heat shield and the heat expansion that happens. It kind of just sits there. Think of you ever get up in the morning and you get out to your car and there's like water all over it, there's dew all over it. It kind of does that. It's similar to like condensation, but it's not condensation. Different phase of matter here. That plasma just kind of sits there. It just sits there, and it makes stuff really, really hot. It radiates heat like crazy. Because you're literally splitting. Well, you're not splitting atoms. You're ionizing them. Split molecules, not atoms. That's right. Yeah, no, I got atoms and molecules confused. If we were splitting atoms, they would do something else. It would release a lot more energy. Yeah. Reentry is way more of way higher compression there. Yeah, enough to make plasma. If your diesel engine would compress enough to make plasma, you'd be detonating something and it would explode. It would fail long before you get to ionizing stuff. Diesel can detonate ping, but it's extremely hard to do. Yeah. Mm-hmm. Zeppelin, right? Like the fuel is going to auto combust before you get detonation, which is why diesel engines are like legendary reliable. Kaboom, that's right. Yeah, but there's not a lot of helium in our atmosphere, Synard. Yeah, exactly, Synard. Yeah, the distributor is a mechanical system on engines. Nowadays, engines are all controlled by computers. It's electromechanical. So basically, give me 1 second, guys. Well, that's pretty neat. So basically, fellas, your engines nowadays just have a bunch of sensors on them. They have a Hall effect sensor that senses the rotational position of camshafts, and then there's a Hall effect sensor that senses where the crankshaft is in terms of rotation. So like it goes from 0 to 360, right? There's basically a pitot sensor, like the type of pitot sensor that or pitot tube. It's kind of a pitot tube, but it's not. It's called a mass airflow sensor. I mean, it basically is a pitot tube. It measures the airspeed in the intake. And sometimes like they measure the temperature. They on some cars they measure the intake air temperature too, if I'm remembering right. So they measure how much air is going in and what temperature it's at. And that information gets basically sent to the computer, and the computer will tell based off of what's called like a fuel map, which is basically like a manual for how much fuel you need to deliver at certain airflows and certain temperatures. And the computer will automatically adjust everything based off of that incoming information. It uses, and don't get me wrong, like dude, this is cutting edge for cars nowadays. The cars can self-learn the fuel maps using neural nets, which is, I mean, it's actually pretty freaking cool. Modern ECUs have neural nets in them to get them to work optimally at all times. Once again, by sensing intake air temperature and the amount of air going in. If you can get the amount of air going in, so mass airflow and intake air temperature, you can precisely dial in the fuel. And once again, some of them use a baked fuel map. Basically, at this air, at this temperature, we deliver this much fuel. And then other computers are self-learning on cars that will learn to deliver the right amounts of fuel to make the most amount of power or the most amount of efficiency. The most efficiency, not the most amount of efficiency. Yes, I'll take one efficiency, please. Yeah, it's really interesting stuff. Oh, really cool. Kind of like rockets with a closed system. I guess. MAP sensor is the pitot tube. MAF is a bit different. Yeah, I used a pitot tube for aviation references. I know that MAP and MAF are different, fellas. Yeah, if I didn't make that clear, I'm making it clear now. I know they're two different things. It's just basically to get people a better picture in their head. I know the difference between a manifold pressure sensor and a mass airflow sensor. Those are two different things. Let me guess, it came from F1 cars. No, not really. The computer controlling the entire thing was just kind of the way the automotive industry went, at least the American. That's what we did in the 80s. Everything went from a mechanical system like that distributor, which uses vacuum to basically deliver, to change your ignition timing, and a carburetor meters the fuel via vacuum. We went from that in the 60s and the 70s to electronic fuel injection and computer-controlled systems in the 80s and the 90s. I don't know about the rest of the world. I think the rest of the world probably followed suit around the same time. Like, not that they're like, oh, we thought of it first. I don't know who invented the computer-controlled system first, guys. I have no idea. I really don't. It came from endurance racing. Yep. Some engines likely turbocharged use both math and map. Yeah, it's basically the Germans, boss. That makes sense, Bill. Yeah, it's really interesting stuff, guys. Yeah, that's tuning. That's like modern fuel tuning. Like, you want to tune an old car with a carburetor, it's all mechanical, so you need a screwdriver. Literally a screwdriver, and you're dialing in. This is what I mean, dialing in. You're turning knobs and stuff on the engine, like in summer car. It's actually exactly like summer car. You dial in the air to fuel ratio on the carburetor by turning the fuel air screw. It's called a metering valve. On a modern car, you just plug in a laptop, and you could just tune the fuel map from there. Or a hammer. Yep. Last carbureted vehicle in the market was the Grand Wagoneer. Yeah. It's fine. Thomas Edison claimed it as his discovery. Yep. But yeah, there are some aftermarket systems. Guys, this is actually really cool, and I kind of want to do this with one of my cars. There are aftermarket systems that a company named Holley makes all kinds of aftermarket performance parts for cars. They started making carburetors, but now they moved into some next level stuff. Guys, like I can take my truck, like the 59 for instance, and we could put a Holley EFI system on it, and we could basically switch the engine from a mechanical system, and we can retrofit it with a computer, and it makes the engine, you can get more power out of it, which is actually really cool. It's really neat. You can take modern like ECU tuning, and you could put it on a motor that's 40, 50 years old, and the motor would probably make like 10 times the horsepower that it made from the factory. It's really neat. You could do all kinds of back engineering with stuff like that. Think about like if it's like if we took the space shuttle, which was like a 1970s design, and we built it again today, and we made the interior look like Dragon. Like we retrofitted it with all modern computers. It would definitely be better and probably less complicated, right? You could do that with old cars. That's why it's cool. It's really neat. I want to put what I would really like to do is put an EFI on the F-250. Now the F-250 is already computer controlled. But the computer controlling system is it's hard coded. It's hard coded into the ECU, so it's not software. We're talking like EPROMs here and stuff, because automotive computers are always 10 years behind the curve with tech. It's just because it takes time to retrofit stuff to get it to work in a car correctly. Yeah, it's more firmware stuff for the tech guys. Yeah, it's all like hard coded onto a PCB. That was ECUs basically until the late 2000s. Yeah, that technology didn't change very much. And then like people started to figure out ways, like, you know how like people can jailbreak phones and stuff. You could jailbreak the ECU and you could flash tune it and stuff. They basically figured out ways to hack the ECU on cars. It's true. Hackers gonna hack, man. That's what they do. A 25-year jump in precision. Yeah, Elvish. I mean, like, dude, even retrofitting the F-250 with EFI, we could probably increase the fuel economy. Yeah, I mean, at the behest of power, but if I'm using that truck to go on long hauls, like driving down to Florida or something, I can think of multiple reasons nowadays why I would want to get like 25, 26 miles to the gallon and not 5. Question. Any info on Van Hai? Is he still going to Kazakhstan? As far as I know, Kem, yeah, he is. But yeah, you can do all kinds of cool stuff with cars nowadays. The Holley EFI stuff is totally open source. Yeah, it's really neat. So you could just program it yourself, or the Holley will self-learn. Yeah, it's really cool. You just literally bolt it on, tell the computer to start learning the fuel mapping, and the computer will find the most optimum fuel map for how you drive over time. It's actually really cool stuff. Now the Fast and the Furious movies make sense to you. Yeah, right. Of course. People screw with the fuel map and they make it run fuel rich all the time and then wonder why they're getting 5 miles to the gallon. Carburetors are for real, man. 2 of my cars have carburetors on it. By increasing fuel efficiency, you're actually increasing power. You're leaning out the mixture, which will increase both the miles per gallon with horsepower. Well, that seems to be, Zeppelin, exactly what Hellfish said right there. So, like, once again, that's rocket science to me. So, yeah, it's just because I haven't messed with it. But yeah, I guess you could fix it. That would be really cool. You could really improve fuel economy that way. Your car has 3 carburetors. Tri-power or 6-pack? At university, you did a research project on hacking cars. All the different brands have things. Different brands and things. People have hacked cop cars via the tire pressure sensors and had full control. How do you hack it from a tire pressure sensor? That's just impressive. Oh, wow. Oh, well, that's something I didn't expect to see today, Forge. We'll have to look at that in a second. Hang on. Before we get into Starship stuff. But yeah, guys, we could go in and we could mess with the truck and stuff. I think that would be really cool. But Holley snipers are expensive. But then again, you know, if you're gonna pay $1,000 to retrofit your car with a computer, right? You're gonna pay $1,000, like, and you're doubling your car efficiency. You're really gonna save money on gas in the long run. All you got to do is drive the car more, and you get what you pay for. So check this out. Because the system's linked together with zero security, ECU talks to tire pressure sensors with no security. I mean, it's a closed loop system, Smirk, so I don't see why. Yeah, I guess that makes sense. I mean, a car is closed loop. Like, there's no need for cybersecurity there because it's not plugged in. It's like people say, oh, the best cybersecurity is a floppy disk because it's closed loop. But if you plug that floppy disk into a computer that's connected to the internet, then, well, nope, no defenses there. Right? Like if your car is sending telemetry, like a Tesla is always communicating with Fremont. It's always communicating with Tesla. Like then yeah, dude, they could shut your car off remotely, and that's the stuff I don't like. I really don't like that. Yeah, no, hard pass. I'll take the carburetor or my own closed loop system. It's a radio transmit receiver system. There's no wire from the tire to the computer. They speak via short-range radio. You have to pair the tire sensors like Bluetooth. That's so weird. Yeah, interesting. I guess I never thought about cybersecurity with cars. That's absolute. I've never thought about it, but that's definitely a thing. You know that like Ford, Chevy, Tesla, especially Tesla's probably really takes that really seriously. Thomas, what's up? New LC36 picture. Note the SBMT on the pad, which I guess would be used to remove the TE. Yeah, I actually have it up right now. Forge linked it right before you did. Hacking a car by Bluetooth. Yeah, Navy. Hell of a time, huh? Like I said, the part of the reason why I'm not too privy to newer cars is because of stuff like that. It's just stuff that, yeah, I don't need that. I'll take the closed loop system. That's fine. Yeah, Smirks. I'll take my key. The key is a pretty good security system, you know. But even then, all you got to do on those trucks is, if you really know what to do, take some couple of things apart with a screwdriver, and you know you can start it. You know, a screwdriver can steal that truck. That's why they were stolen so many times. Not really good in that regard, but yeah. Anyway, let's flip back over to space news, guys. Here, let's take a look. So, who posted this picture? Robert Gittin, who is a life support engineer at Blue Origin. Okay, what's Rob doing? Hey, is that a? Are you dabbing? Okay, that's Complex 36, and it looks like they have a big self-propelled modular transporter right there. Yeah, an SPMT used to move the transporter erector. That's cool. Yeah, Ford happened to place that handy theft assistance jumper under the hood of the F-150. What were they thinking? Mile, I'm saying that as a Ford guy. What were you thinking? What were you thinking? People just wouldn't be able to open the hood? You break the window, unlock the hood, you could start the truck. Like, what are you doing? Like, oh my God. Why would you do that? Also, what the heck is this? Check below. All right, I'll check that in a moment. So there's a new picture from Complex 36. We haven't seen that. Haven't seen this picture yet. Jesus Christ, Rob. Yep, all you need is a screwdriver. Yeah, I was messing with that yesterday. Yeah, you like that, Five Rings? It's very revolutionary. Well, I say, all men are created equal. Yes. Not British. Anyway, what do you want me to see here? So this is coming from Will Buxton. Okay. Remember, Scarab's Tech imagined Alpine drawing. If what we are hearing about Merc is true, maybe he wasn't so far off. All hump and no side paws. What? So the Mercedes is running no side pod. And it looks like they're Oh, that's not a bad idea. I know what they're doing. Interesting. Interesting. Ah, I see it. I see what they're doing here. That's actually pretty damn smart. I know what they're doing. You guys know what they're doing? No side pod. So usually there's a huge intake right here. It's called a side pod because it's a pod with an intake and it's on the side. I know. Engineers, great at naming things. Last. Okay. There's new hardware at the Cape. Yep. New methane tanks. Pretty cool. So that pod is usually where the radiators for the engine are. There's heat exchangers in here that are attached to coolant loops on the system, and it keeps the motor cool. Mercedes, dude, if that's the case, if that's what the car looks like, that's very interesting. They opt to, it will look very odd. It looks like Mercedes opted to run with no side pod. So that means what they're doing is that the intake for the side pod is down here. That's why this all bulges up. And that's actually pretty smart. It's smart for a couple of reasons. One, if you have an intake underneath the car, it's sucking in air and creating lower pressure under your car, so the car will hug the ground. The lower pressure you make underneath a car that's going fast, the more it can push the tires into the ground. The second part is low pressure air is extremely cold. So that means they don't need to run a bigger intake because they're sucking in air at low pressure. Sucking in air at low pressure at the right airflow, right? We'll be able to cool the engine more efficiently. That's really smart. Very smart. We'll see if it works. Might not work. They don't get the intake size right underneath that car. Their engine's going to overheat because they're not going to be able to move enough air. But then again, air at low pressure is moving a lot faster. So if you have air at high pressure, it moves slower. But you bring in more air. But the air is hot and it's moving slower. You can get the air going in faster at lower pressure, but you're not moving as many molecules around. But it's colder. So when you exchange the heat, you ideally want cold air. How it perform in the corners? I'm not sure. But that's really smart, tucking the side pods underneath here. The side pod is down here. The intake, instead of facing that way, it's facing this way. Corners are the most important part during races. Yeah. Well, that's probably why they have these side elements here. They're probably going to need, when the car's like going around a corner, they're probably going to need to pull in air, a lot of air underneath the car. Interesting. Interesting. If it looks like that, that's going to be pretty crazy, dude. Where's the exhaust for these intakes? Back here somewhere, Swishio. Yeah. You ideally want the low pressure air going in. It exchanges the heat, and then you basically want super low pressure coming out the air intake at the back. But the problem is when you heat that air up, it's going to compress, right? Because the ideal gas law. So it's a challenge here. You want low pressure in and you want low pressure out. But the problem is the reason why you're taking in intake air in the first place is to exchange the heat that's made by the engine. So that low pressure air is going to go in, it's going to exchange the heat, and it's going to compress outside the radiator. Or after the radiators, after it goes through. So now what do you do with it? If it was me, I'd dump it over the rear diffuser. If you dump it over the rear diffuser, you can create more downforce that way. But you really have to make sure that it's, post radiator, that it's conic. The intake gets bigger over time. Because if you pinch that high pressure air, you're not going to be able to cool it as much. Air will back up in the system and high pressure will go out the front. Yeah, that's no good. You don't want that either. You don't want backflow in a radiator. That won't end well. Literally right now, Laserman. Those drawings are not accurate and were done tongue-in-cheek. I know. I know. Because when we first looked at them, I said this is an approximation. Or no? Did we miss that part? Here, Starship News. So this footage is coming from our buddies over at NASA Spaceflight. Bokajigal, Mary, and Nick and Sweeney are the two photographers that they have down there. You guys know the drill. It's your boy NASA Spaceflight. Go over there and hit a sub button for me if you could. Support them so I can put my crappy commentary over their videos every day on stream. It's your boy NASA Spaceflight. That's savage, Limprod. A little windy. Look at the deflection on the cranes. Goalie, you see that? When it's sped up footage, man, those things are really wobbling around. But yeah, you guys just, okay, real quick, last thing from the car conversation that we were having. If you guys are interested in fuel maps and tuning and stuff, if that's like the kind of techie stuff that you guys would want to see, just tell me. Seriously, just tell me. That Holly Sniper is expensive. But if enough people show me that you want to see some, like a point where the tech world and the car world kind of cross each other, tech world, car world, you son of a gun, I'm in. Just let me know. Cause I've been wanting to do that for a while, and that Toyota has the Y and the A X'd out on it, so it said toot. Toyota. You want an HEI on the 59? So why? So we can make it a going to town rig? Yeah, header tanks, dude. Header tanks on Super Heavy. That's a booster section. That was a good episode, Buck. It's really cool. It's a little bit shy. It doesn't want to come out and say hello. Do you think that the Ford Maverick with the turbo is a built-to-last car? Well, it depends. Jen, Ford Mavericks are cool. It's a cool car. If you put a turbo on one, as long as you did your engineering right and made sure you didn't put too big of a turbo on it or something, so that, like, if you put a turbo on it, you're probably going to need a different carburetor because a turbo will change your air-to-fuel ratio in favor of air, and your engine will melt. You'll get danger to manifold. Beep, 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 beep. Shut up! That's why, spraying nitrous too quickly can make an engine not happy. It's factory turbo hybrid. Oh, the truck. Oh. I thought you were talking about the car. I thought you were talking about that Ford Maverick. You say Ford Maverick, that's what my brain goes to, not that Ford Escape with a pickup bed. Hey, Connor. Mint! What's up, Vernock? Yeah, I think that. People put turbos on these and actually get like 30, 40 miles to the gallon because it's got a straight 6 in it. Yeah. Actually, those cars would be a really good daily driver because these things are super light. American cars in the 70s, they really tried to reduce all the weight, or the late 70s, early 80s. They tried to get the weight down to improve fuel economy because of the fuel crisis. So if you take those really light cars and you put like a turbo in them for the inline 6, and then you put like a electronic fuel mapping on it, you put EFI on it, you can get 30, 40 miles to the gallon in those old cars, which is actually pretty cool. Yeah. Yeah, you say Maverick, I think of that thing. The truck, yeah, that thing's cool. Get the all-wheel drive version. The two-wheel drive, well, I'd get the all-wheel drive version if I was going to buy that. I don't hate the Maverick, the new one. I don't hate it. It's literally a Ford Escape with a pickup bed, but hey, whatever. It's a parts bin car, and you know what? every once in a while, an automaker, you know, you can't just make Corvettes all day, right? Like, I'm not trying to knock Chevy or whatever. Chevy does the same thing. You make a really cool car, right? But not every car can be a cool car. Some cars have to be utilitarian in purpose. This thing is designed. It ain't a pickup truck, guys. It's a Honda Ridgeline is more of a pickup truck than this thing. This thing is. It's like I said, it's basically a crossover SUV with a pickup bed. That's it. You're not going to go off-roading with that. That's really designed for people driving around in the cities that want something with a little more room. Mavericks are sweet. The car ones. Put an aluminum LS under the hood and good suspension. Yes, please. Yeah, no, I'm in. Same with Chevy Vegas. Yeah. Yeah, and Plymouth Dusters. Those are cool cars. Yeah, I like those mid-70s coupes. Mile long. They're cool cars. Duster prices are insane. You see the price? See the price for a crappy Duster nowadays? It's like 10 grand for one that has holes in it for a Fred Flintstone special. Freaking 10 G's. You got to be kidding me. Jackery, let's see. So those were going to the launch site yesterday. Okay. It's definitely a huge long shot, but I applied for an internship at Sandia National Labs for the development of the next generation solar panels. Not expecting much for it, but you miss every shot you don't take. Yeah, Jackery. Good. Yeah, chance favors the prepared. Remember that. So make sure you're prepared for that interview. But yeah, of course, try it. You never know. Flykin, what do you want? I understand that a turbo on a car uses the car's exhaust to spin the turbine to make the compressor make boost. Yes. On a rocket engine, how does it utilize the turbo without melting it? Cryogenic propellants? Yeah. Yeah, they're terrible, goalie. I'm happy I bought Tough Enough when I did. And all my other cars, dude. So, Flykin, on rocket engines, they run really fuel rich. They do not run stoic. If you run stoic, the rocket engine will melt. There's just no way to get rid of that heat. Thermodynamics is a real pain in the butt. Ask any engineer. So they run really fuel rich. It's part of the reason why Falcon 9, when it comes back, is covered in its own soot. Because they're running fuel rich to keep it cool. Because the material science isn't there to run a rocket engine at stoic. It'll melt. NTRs are extremely fuel rich. You're not wrong. It feeds the fuel through there instead of the exhaust. I thought it was exhaust. It depends. Depends on the design. It really does. It depends on the design. No, they feed the propellants. They feed the propellants in there. So they mix liquid oxygen. So like the Merlin, for instance. The Merlin engine mixes liquid oxygen and pit stains. It mixes liquid oxygen and kerosene in a very fuel-rich mixture, and that turns the turbine, which turns the turbo pumps. I'm good with how I am right now, Connor. One day, can you make a moderator recruiting stream so you have reinforcement? Just a suggestion. I copied this message in case you don't notice. I have enough moderators right now, Connor. I appreciate it, but yeah. Still want to see the Coronet turned into a sleeper. Yeah, I gotta get it out of my parents' driveway, dude. I gotta get my cars out of my parents' house, dude. I have to, and we gotta buy a house to do it. I don't want to buy space. I'd rather buy a house. Anyway, yeah, let's get back into the Starship stuff. I really want to know how it feels to be a moderator and what you see as a mod. Yeah, asking for moderator is a great way to never get it, Connor. Yeah, yeah, you basically just sealed the deal. You're never gonna mod this stream ever. Like, I'm not trying to be mean, but yeah, that dude, don't ask for moderator. Yeah, please don't do that. Buying a house on the verge of a Great Depression is maybe not a good idea. Yeah, you know what's worse, Jack? Renting during the Great Depression. Yeah. So this is the new booster section. That's the hydraulic power unit for the gimbals right there. And then that's the COPV for air start capabilities, so they can restart the engines when the thing comes into the... Hey, okay, it's leaving. Okay, all right, bye, I guess. Guys, you can always refinance loans. It happens. Interest rates get adjusted over time. I'm learning all about this. So, you know, you can buy in at a high interest rate and then you just refinance over time, you know? You can refi it and get the payment down. It's not a big deal. And before you say, "Well, I mean, that my realtor and the mortgage broker literally said the same thing." So, I don't mean to regurgitate other people's opinions, but I'm pretty sure they know more about this than you guys. Yeah, look at that. Note that there's single COPVs here. See that? Booster 4 has double COPVs. There's 2 of them. Now there's only one. Bird. Yeah, B0, I don't see... Real estate prices going down in Boston is about as likely as real estate prices going down in the Bay Area. It's not going to happen. The COPVs are stacked 4 to 5 in line now, and there being 2 banks of them. So there's going to be like another one right here? Wait, let me see that. Let's take a look. So this is coming from Lunar Caveman. I'm Bill Ensit. I work on the Space Coast and focus on Moon to Mars. Stacking COPVs generates less than a quarter of the drag of the Booster 4 aero covers, and it adds a lot of lift on the 2 big strakes for return to launch site. Return altitude will have these down and all 4 grid fins providing pitch authority. Whoa. Yeah, see, Thomas, this furthers what I'm thinking, dude. Super Heavy's going to come in sideways. They're going to carry that momentum. It's going to carry that momentum, dude. Dude. Yeah, now, SpaceX will land this. I'm convinced. Yeah, that right there kind of shows me everything I need to know. They will be covered by the nominal segments. Yeah, those triangles that we saw come in there. Yeah, that's going to generate a ton of lift, fellas. Yeah, that's going to generate a lot of lift. You're going to get insanely... When the booster's flying back, you're going to get insane low pressure right here at the bottom of the booster. It turns the bottom of Super Heavy basically into a lifting body. Holy frick. No, it can't be. They're not going to generate enough lift from that. there's going to be extremely high air compression right here and extremely low air compression right here. You guys remember Freedom? You guys remember the Freedom rocket? Literally that. Yeah, Snib. Yeah, remember the cigarette booster. Dude, literally that. You can do that. You don't need a freaking big wing, right? You don't need, you don't, like, in real life, you could just put some strakes on the side of your vehicle and it'll generate crazy amounts of lift. I mean, you know that NASA figured that one out in the 60s with the HL-10 and the X-24. Look. See? Great picture, by the way. See? They figured out that, yeah, you just need to create basically super high pressure right here and super low pressure on the sides, and it'll fly. It'll fly just fine. The X-24 kind of takes that to the next level, though. Well, that's the X-24A, and then they switched to the X-24B. Look at that thing. Yeah, that's exactly what it's going to do. Mile? Yeah, that's a lot of surface area, man. Dude, that thing will fly. Like New Glenn, it'll do that. Yeah, that's just a different way to do it. The problem with the X-24 is that thing is super susceptible to side slip. Super susceptible to side slip. Nailed it. Yeah, we raided NASA's technical archives and we saw that some of the testing stuff from this. It is super. This thing really likes to just flip out because look where these air surfaces are. See where it says 13,551? That doesn't do anything when you're flying like this. When it's flying like a spacecraft, like re-entry, you have to basically nose this thing down into the ground, or else it'll drift you out of control. These things needed to be out here. They needed to be straked out on the sides. That, I mean, once again, that's not my judgment. That's right from NASA's technical archives. They needed to be like that. Interesting. And that's why Super Heavy has grid fins. Yeah. But, yeah, see? Dude, yeah, no, she's going to fly. More than Falcon 9. This thing will fly. That's crazy, dude. Dude, that's a really smart solution right there. And Thomas, once again, this goes back into what I'm saying, dudes. Super Heavy is not going to land like straight down on the chopsticks. It's going to come in sideways. I'm telling you. Picture the two runs on the chopsticks like a small runway, and the thing's going to come in sideways. That corroborates that theory pretty hard. That's how they're going to do it. They're going to use the momentum of the booster for precision. So the thing's going to come in sideways, right? And when it gets within the threshold for the chopsticks, that's when it'll compensate and it'll straighten out. So like it'll come in like this, and then it'll turn right straight down before the engines get below the chopsticks, and then it'll grab it. They're gonna use sideways momentum to keep it precise. Like I said, that pretty much corroborates that idea pretty hard, that this thing is going to come in sideways because it's asymmetric. I disagree, because if it's sideways, then the bottom will swing and hit the tower. It'll come in slightly sideways like Falcon 9, but not much. You don't need a lot of momentum to get this thing to come in precisely, Smirks. But yeah, so you're basically saying I don't think it's going to come in sideways, it's going to come in sideways less? Yeah, you know what? They got a word for that. It's called coming in sideways, right? Okay, so maybe like this. That was over-exaggerated. It's not going to do this, right? It'll probably come down like this and then kind of go a little bit to the side. It's going to come in sideways less. No, Smirks, I understand what you're saying. You're right. I mean, the runway, remember I said the chopstick's like a runway. You don't have a lot of runway. Yeah, so that favors more down than sideways, right? But it's still going to, I'm telling you, it's going to use the momentum of the booster. And if the booster is swinging around after, it's no problem. the 15 degrees of gimbal should be able to compensate for any swing. Yeah, okay, I agree with that. Yeah, I think that's what it's gonna do, dude. Sideways momentum. That's how they're gonna get it precise. You know, people say, oh, you're not gonna be able to catch a pin like that. Well, if it's coming in sideways, it will. Yeah, absolutely. Like, it'll be like a giant pendulum. Pendulum is really easy to predict where it's going to go. Super heavy will basically come in and kind of pendulum itself onto that thing. That's, once again, very over exaggerated, but that's the idea. Reverse Astra. No, not like that, Inco, but kind of. It's Space X, not Space Y, okay? Yeah, Mile, I agree with you. They're going to use the momentum of that booster to get it precise. Dude, that sealed the deal. I think they'll catch one. I've been kind of honing in on how they're going to do it. That right there, that tells me everything I need to see. I'm going to favorite that and probably talk about it later. Yeah, that tells me everything I need to see. That's really smart. That's an ingenious solution by SpaceX. It's really, really smart. Also, they copied me. My cigarette booster was doing that last year. Just saying. Just saying. It's my idea. It's my idea. Stop copying me, Elon. Okay. That was a joke, please. It was a joke. If anything, I copy them. It's just a joke. But also, stop copying me. Further proof that he watches you. I know, right? If Thomas, if Super Heavy finds some landing gear, I'm going to be really annoyed. I got the Captain Price, yeah. Yeah, Chet, so you're the new FNG, huh? Kinda name is Chet anyway. Had a muppet like you get past selection. To your point, I would imagine the apex of the slowdown thrust would be away from the launch tower, then ease off with max thrust. Yeah, Jeep guy, yeah, maybe. I know what you're saying, yeah. With my way, they're going to point the engine basically at the tower. I'm sure that's going to end well. But yeah, maybe the chopstick is enough distance. I don't know. Or maybe they'll come in over the tower. Like, I guess that's possible. I don't know why you'd want to do that. I mean, no matter what, that tower is going to get hit with a rocket blast. Like, I don't know any other way around it. Leaked. Super Heavy to get a ring with Booster 8 with jet engines mounted on it to land on Highway 4. I would... Actually, Thomas, I put more thought into how... I put more thought into how the cigarette booster would work. Dude, you could get it to work in real life. It would be kind of difficult, but you could do it. The wing shape would be very, very strange. You wouldn't just have a torus ring around the booster. It would be, what's the way to say it?
Discovery, go at throttle up.
I'll see if I can draw it. Give me one moment. So you have the booster like this, right? And you have your engines. It wouldn't just be like a circular wing like this over the center of mass. No, it wouldn't look like that. Because this thing is falling, and the way it's falling, you'd want the wing to look like this. Like that. Yeah, you'd want it to taper on one side so you can get the air up in there and make a ton of lift off the top. And then the back of the shape, or the bottom shape of this would kind of probably go down like that. It would be like a bent ring almost. Maybe not even with this point out the other side. It would be like, instead of the wing, if you're looking at it from the side, instead of like this, it would be like this. Or better yet, like that. That would generate the most amount of lift. Like it would be like an air intake on a jet. Yeah. It would be like an air intake. Kind of like an SR-71's air intake. Basically that. Yeah. Basically that. How would it affect it going up? It would be stabilization on the way up, dude. Yeah. Yeah, circular glider. Yeah, exactly that. Yeah, that guy right there. Mm-hmm. You're digging the chops? Thanks, weather guy. Yeah. Yeah, that. Mm-hmm. Looks like a hybrid of a toroidal wing and a supersonic biplane. Yeah, it's...
Discovery, go at throttle up.
I was thinking about it more because with that circular wing, you're not going to generate a lot of lift because boosters don't fly like this. They're coming in and the air is coming like this. So you're going to need a high angle of attack to get it right, especially if you're coming into land, right? So... Would you want that on the top side or the bottom going up? You'd want it facing space on the way up, goalie. Yeah, facing space on the way up. Mm-hmm. Hey, Diamond, 65-month resub. Thanks. Because the rocket is flying this way on the way up, goalie. If you're looking at it from the front, it's just a circle, so it's not going to cause that much drag. I mean, it will cause drag, obviously, but it wouldn't cause any more drag than a stabilizer. Yeah. Dude, there's got to be a reason why people haven't done that. There's got to be. There's got to be a reason. We should do that more. Should mess with that more. With the limitations of Kerbal's wobbly physics system, I think a system like the Baikal booster would work better. Yeah, that's why I was able to routinely land Freedom boosters. Structural limitations? Make the wing surface carbon composite. Yeah, there's that new booster segment right there. It's moving a crane saddle and some counterweights around. It's for the Grove crane. You can tell it's for the Grove crane because of the way it is. Yep, and there's your boy. That guy's driving it, the guy with the briefcase. Oh, okay, Sarnard. Yeah. Yeah, Synerd, I know that. That's why I came up with that weird wing shape. Yeah. Dig a hole. Is there a launch scheduled yet for Starship Red? Nah. Programmatic assessment should be done in about 20 days. Should be. Hopefully. If it's not, I'm going to be a little upset. Yeah, it'll be really cool to see. I agree. I agree with you. I like that truck. I know it's a Chevy. I don't care. It's cool. Spine in there. You saw some of the other test flights? Yeah. Haven't seen much lately. I mean, 15 was still less than a year ago, wasn't it, though? When was 15? 15 was the summer. What was it, like July of last year? So it hasn't been that long, guys. I mean, considering if you go and watch SN15 and you look at the launch site from that footage, it's a little bit different. May 5th, 2021 for SN15. One had a RUD. Yeah, all of them except for SN15 had a RUD. SN15 and Starhopper. Why do they keep making boosters if they can't fly them yet? Rapid prototyping hired. I wouldn't be surprised, Tomast. "11 was the best run of the bunch, though." Dude, I wish we had pictures of that. That was a savage explosion. The thing just obliterated itself. Yeah, right, goalie. 11, that hard start obliterated the entire propulsion segment. I mean, they're still picking up pieces of that thing. Did you ever end up going over the NIAC winners from a couple of Fridays ago for Space News? No.
Discovery, go at throttle up.
Mile, 16 months. Hey, look, it's button time again. Glad to be back. Thanks, man. I know, AJ. That's what I love looking at every day, dude. That's why I love looking at this footage all the time, because you see the people walking next to it, and it's just like, damn, dude, this isn't a render. That thing, look at that thing. This is real. That's a real thing that's going on right now. I don't hate that. You're on one of the Phase 2 teams? That's cool, man. I'll check that out off stream, dude.
Discovery, go at throttle up. Discovery, go at throttle up.
Hey. Josh, 21 months. I'm not reading your stuff. Screw you. Saljut, 58-month resub. Thanks, buddy. Wait, did you change your name? Cool. All right, we got a couple more videos from our NSF friends over here, so let's go over here and check it out. Do all those heat panels offset the center of mass by much? They're super light, breakneck. They have the consistency of like maybe a packing material, like styrofoam or something. Or that thing that's not styrofoam that like packing peanuts are made out of. It's about that consistency. It's not that. It is not packing tape. They didn't put packing material on the side of Starship. It's unifibrous reinforced oxidation resistant composite. Whatever that might be. But yeah, it's about the consistency of styrofoam. Yeah, so, no, not really. What is that pressure sound? It's probably them doing something with the tank farm. I don't know. Or it could just be a jackhammer. Or a nail gun. I don't know. Crews work on 22. Really? What? Really? Aren't they like as heavy ceramic plates? No. Styrofoam. Super light, super porous. Yeah, styrofoam. Mm-hmm. Yeah. That was a bird. I'd like to remind everybody that this thing on the right here has been 40,000 feet up in the air. It's about 12 kilometers up. Yeah. 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 That thing flew. Fell with style, let's put it that way. Yeah. Cerebral, look at Hired's link. These red crane parts were moved to the launch pad. Interesting. Give him credit for the trip up. It flew pretty good. Yeah, Devlin, I only said that because if I said they flew pretty well, someone would be like, well, it didn't really fly. But I said it didn't really fly, and now you're saying that it flew. I lose either way. I don't know why that's funny. Oh, man. The 28th of March, Game Coder. I don't know why that's funny, but that's really funny. Hey, man, I'm just going over there. All right. Oh. Oh, 350. I like that truck a lot. That truck's really cool. 350 dually. Oh, it's neat. It's neat. I want it. Okay. All right, moving on. Bird. Fagioli. I don't know, Cerebral. No, the shuttle tiles are silicate based, and SpaceX's are composite based. I moved around that transport stand, huh? Bird. Bird. All right. Dodge. Chebby. Chebby and Bird. Dude, I'm so happy I got the key working on the truck. I'm sorry, you don't know how happy that makes me. I don't have to freaking hotwire this stupid thing to start it every time. It just starts like a normal car. I love it. It makes me so happy. Are these tiles as susceptible to damage as the shuttle tiles? Well, yeah, of course they are, Naroku, but the thing about these tiles is that they don't ride next to an external tank. Tiles are first on Super Heavy's design. The problem with the external tank was that the foam would cavitate in certain conditions and it would come off and hit the tiles because the shuttle was on the side. Starship is not on the side, so you don't really have that problem. Now, don't get me wrong. The tiles are still susceptible to foreign object debris hits anytime. I mean, you could hit a bird on the way up. I mean, that would suck for the bird, but yeah, they still are. They can get punctured, of course, but it's less likely to happen because Starship's up at the top. Wasn't there for that. Key is working now. Mint, I'll show you. The external tank did hit a bird at one point, yeah. I don't know if I told you yet, but fagioli means beans in Italian. No, I think you may have told me that, Swishio, or I may have known that. It's probably you telling me, but that's still funny. Do you think they'll suffer from the same icing conditions as the shuttle? What do you mean, icing conditions, Niroku? Dome cap. Nice fifth wheel. Big Tex. The Big Tex fifth wheel, boy. I tell you what. I tell you what. It's an elevator, guys. You can tell it's an elevator because of the way it is. That's right. See that? It's an elevator. Ernock, I rebuilt the steering column, dude. I rebuilt the steering column. I fixed the ignition actuators in it because they were hogged out from using a screwdriver to start it. I took the whole steering column apart. New bearings. Shims. New ignition actuators. Yeah. I partsed out another steering column from the junkyard, from that truck from the junkyard. I took parts off of that. I got new bearings, and I made one good steering column, and I put that back in the truck. That's terrible, Sipnet. Heck, a starship's supposed to have standard tile shapes, right? Yep. So for a crewed mission, just pack a few spares. Do your on-orbit inspection. If there's a busted tile, stick a spare on with an EVA. Well, yeah, EVA or a robotic arm can't have, but yeah. Mm-hmm. Give me 1 second, Bill. This is the parted out steering column. It has some parts in it. It kind of works, but
Discovery, go at throttle up.
in there, this piece that's inside of this housing that goes back and forth, yeah, that was hogged out on the F-250 steering wheel. Or steering column. I didn't take the one out of this one. That one is still in there. If you see it, it's that plastic piece that's in there. See that? I bought a new one, and I pulled this one out. I'm not sure where it is, but yeah, it's totally shot. It's from someone sticking a screwdriver in there and doing this, because when the key barrel goes on this, people just stick screwdrivers in there to start the truck. Yes, that'll work. Yeah, mine was beyond screwdriver though, so yeah. And this is a tilter column too, which is really cool. This one needs new shims though. I put bearings in this one. It has new bearings, but the shims are. It needs shims. You know, you probably could have 3D printed that part, maybe. Yeah, nope. Now that PLA would have broken. Yep, alright. Yep, guys, Brimo just stopped me while I was putting the steering column away to tell me that she hates these, so they stay for another day now. Yeah, sweet. Do I spy a shuttle in a box? Oh, it's not in the box, it's just the box. So yeah, Bill, I fixed all that. I rebuilt the column, took it all apart, put it all back together, cleaned it, put it back in the truck. Now I have a key. My truck has a key for a change that actually works, because I was what I was doing is bridging the starter solenoid through the trailer brakes with a starter button. Yeah, it worked. It bypasses the neutral safety switch though. Ask me how I know. If I recall correctly, you can get nylon filament. I don't think my printers will do that, but actually, Signer, shut up for a second. Cat, nice S10. Shut up for a second, real quick. Fellas, we have an Xbox. I have an Xbox One. And we had a conversation about consoles the other day. And I was like, I don't know what consoles I have. We have an Xbox One. Remo uses it to watch Twitch streams. And I went and looked at it, and I saw that the Xbox Kinect was there. And I had an idea. The Xbox Kinect is a LiDAR mechanism. With the right adapters, you can plug that into a computer, and you can 3D scan things with it. I bought the adapter. Yeah. I don't know what its sensor resolution is, Smirks. It doesn't matter. You give me an interpolated. You give me a mesh. I can interpolate what it is. I can 3D model. Remember? Yep. So yeah, I have the adapter and a laptop, and I think I'm gonna go scan the coronet or something. See what happens. 3D scan with iPhone now, right? I don't know. I mean, I can. Yeah, we could just scan cars. Should be able to do it. It should be able to get the mesh. You could 3D scan things with a regular camera. The Xbox 360 Kinect camera. I have an Xbox One. I don't know. You can 3D scan with an iPhone pretty good. Not precise, but pretty good. iPhone scans real good. You should see the setup I have. You wouldn't download a car. No, but I would scan one and 3D print it. There's no downloading involved. I don't know, Synerd. I'm not familiar enough. I just bought the adapter and I'll report back with my findings. Okay, boom. There are tons of ways to scan a cat. Scan a cat. Right. Yeah. Yes. Scan a cat. Right? Right? Duh. Nice. A projector that puts a pattern on the object and a camera off on an angle that looks like how the pattern deforms. Hey, Mutter, you want to find like a Dana 50 or something and 3D scan that for me and then send it to me? So, I can, yeah. Right? We got one more video, dudes. This is the one I wanted to show you. There's some cool stuff in this one. Just watch. I don't know, Synerd, maybe, yeah. Kind of neat. No, I won't watch. All right, fine. Let's back it up. This thing is looking pretty finished here, guys. Yeah, not a lot of scaffolding left. I told you could always tell how close the pad is to being finished by the amount of scaffolding and rigging that you see. There's still a lot of rigging hanging around here and a little bit of scaffolding over there, but that's nothing compared to the scaffolding that was on this thing like 2 months ago. But is it looking finished? No, it's not. It's not look finished. It's look different. Jesus. Almost a year sub already. 11 months. Thanks, man. Oh, look. They're repairing the road. Ha. Again, because it gets absolutely dumped on. What do we have here? Let's take a look. Huh. I'm trying to figure out how this thing goes together, and I'm really kind of at a loss here. Yeah, Bill, trucks. You don't get the grade right, it's not going to work right. That's not a structural stiffener, Jared. I mean, well, you know what, Jared? I don't know for sure. My gut's telling me that it's not, but dude, honestly, your guess is as good as mine. I have my theories for what that looks like. I'll show you guys something. That looks like something that I've seen elsewhere around SpaceX's properties. But I don't know for sure. So this debate started in my family. Do you stand with your knees locked or no? Locked. Locked. So, fellas, I'm going to pause it there for a second. That looks like something else that I've seen around SpaceX's headquarters. That shape, particularly. Now, that could be a Starship elevator. It could be a payload dispenser. I don't know. What I do know is that it does look like an elevator. Somewhere on this map at one of SpaceX's facilities, there's a copy of this, or something that looks very, very similar to it. We go over here to Hawthorne, right? This is SpaceX's headquarters right here. You can tell it's SpaceX's headquarters because of the way it is. So there's SpaceX's parking garage right there. There's 1019, the first Falcon 9 that ever came back, right? Northrop Avenue, right? And then you go over here to the Boring Company. This is the Boring Company tunnel right there. That was the prototype Boring Company tunnel that Tesla made, or Boring Company made. And then there's this thing next to it. See that thing? That lattice looks like that. Not as beefy as that, but it looks exactly like it. And it's about the same size from what I can tell. Now, how can you tell? Take a look. Nine meter core. So that means this thing is 9 meters across. Starship's tank diameter is 9 meters. So that tells me that that's whatever that is a prototype of whatever that is, and that looks like an elevator. But I could be wrong. I don't know. I wonder if they're going to load cargo like the car storage elevators in Japan. I don't know, but I'm going to go out on a limb and guess that that's an elevator. It's 9 meters in diameter, and I found that a good while ago when I was, you know, doing my Google Earth peeping thing where you can go find SpaceX prototypes sitting in a parking lot right here. Like that landing leg right there. So they want to build underground colonies on Mars. Got it. Yeah, I don't know. But it definitely looks like that. I don't know. It could be a payload dispenser. It could be a track for the elevator. I have no idea. Don't know. My money's on elevator, but I don't know. I'm not sure. Peeping Johnson. Yes. You peeping. Not a peeping Tom. You're a peeping Jeff. Peeping Jeff. Why put it in a barrel with tile points, though? Yeah, I don't know. Wait a minute. Wait a minute. No. No. That is a payload dispenser. It's not an elevator. Elevators, yeah, it's a payload dispenser. I know what that is. Oh, yeah. Okay, so think about it like this, guys. So that barrel segment, Thomas, has tiles all around it, right? But we know that Starship is going to need, like I said, with the payload bay doors, right? We know that there's some kind of cargo pathfinder out there. I don't think they put the payload dispenser inside of the cargo bay pathfinder. I don't think they did that. But remember how I always said that Starship is going to have a regular sized payload bay, or not a regular sized payload bay. The payload bay doors are going to have to be on the side. No chomper fairing, right? I know what that thing is. That's a Starlink dispenser. Yeah, I'm pretty damn sure. It's going to dispense Starlinks kind of like out the side. Like and they're just going to be stacked, and they're going to, this way they don't need to like spin the Starship. They'll probably like, how would you do this? Let's think about this logically for a second. So would you want to just shoot them all out the side all at once? Well, how would we do that? Like a Pez dispenser almost. Yeah, exactly. That's a good way to say it. Like a disc shooter? Yeah, or a Pez dispenser. Exactly, because you wouldn't want to just yammer them all out. One could get caught. So you'd have to just pop one and then pop the next one and then pop the next one. It won't be like Falcon 9 where they just let them go. Because that means you would have to spin Starship end over end because they're shooting them out the side and not out the top. So if you're spinning it end over end, you're going to deploy a satellite and the back's going to knock it out. So you have to like deploy one or just shoot them all out the side like a piston almost. Yeah, it's a Pez dispenser for Starlink satellites. That's what that is. Let me just look at it one more time. Do we see like tracks or rails or anything? Those things. Those are your rails. See how they're not touching anything? Those are rails right there. Have starships spin along the long axis. Yeah, Mutter, that would do it. Yeah, do a barrel roll, so to speak. And every 1 RPM you deploy another satellite. It's a frickin' Pez dispenser. That's what it is. It's a frickin' Pez dispenser. Yeah, so it'll deploy one, it'll spin around, it'll deploy another, spin around, deploy another, spin around, deploy another. Or they'll just all out at the same time. I don't know. That's not many Starlinks. Yeah, I see a lot of people saying that, but that's not many Starlinks. It's not very many Starlinks. Guys, they could stack like 4 or 5 of these things on top of each other inside a Starlink's payload bay. This thing could literally carry like 3 times the amount of satellites, of Starlink satellites that a Falcon 9 can. You could just stack those things on top of each other. Yeah. 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 It's a Pez dispenser. Or like a... You know those like I don't think they'll be spinning the satellites. You know those things that shoot the little foam discs? Kind of like that. It's got to be. I mean, it's either that or an elevator. It's one or the other. NASA Space Flight says potential payload dispenser. You know, it could be that. It could be an elevator. Or even knowing SpaceX, they might use the same track mechanism. Why wouldn't you? Use the same thing. So Starship is easily configurable. Right? Like, that makes sense. Cool. That's neat, man. That's really cool. That makes me happy. Hey, Bren, what's up? Not many Chet users can fit into it. There's ship 20 in the background there. I really like that weather vane, I'm not gonna lie to you. I don't know, Bon. Yeah. Also, how much do you think those flex hoses cost? Those steel braided flex hoses. These are probably expensive. Yeah. Yeah, these guys right here. Those are probably expensive. Steel braided flex hose. Cryogenic rated. Yeah, those are see those tubes right there? They ain't aluminum tubes, they're steel tubes. Don't say flex hoses! Oh my gosh. Dude, that's like $5,000 worth of hose right there just sitting out in the parking lot. It's probably more, dude. I don't even know. I know it's at least that much. Those are expensive hoses. Because they're pipe that flexes, guys. That's why they're expensive. They're hard to make. Let's look on McMaster. Oh, they moved the QD out of the way. That means, what are they? You got to tension the chop cables? You know what you could do with steel tubes? You were already on McMaster before somebody said that? Call the exterminator. Somebody call for an exterminator. They are a pain to receive and having to verify lengths. Oh gosh, that just sounds not fun at all. Wide and high bays. Yeah, that's right, Uncle Bill. You got it. Yeah, Swishio, it's just the brakes. They had that out. The brakes do that. They can combust. The shoes are steel and graphite. Yeah, they can catch on fire. Be all right if we make the fog. Bum 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 ba da dum bum ba bum ba bum ba bum ba da bum bum ba bum ba bum ba bum ba da dum. And she's buying a stairway to heaven. I can't sing all of it. I don't want to get sued. I wonder if they'll keep manually tying back those nose flaps. Probably when the thing is stowed, Bon, yeah. And as we wind on down the road, now I got it stuck in my head. Nice, Boom, yeah, that's right. Yeah, there's the stacked COPVs. Dude, that thing's gonna fly. It's gonna fly. That's gonna be insane. All right. So that's the footage coming out of NASA spaceflight. Once again, steady progress. Steady progress. But I'll remind everybody that the SpaceX programmatic environmentalist, the FAA's rewind 15 seconds. The FAA's programmatic environmental assessment of SpaceX's launch site. Thanks, Prem. Is supposed to conclude on the 28th. So we got 20 days, or the FAA has 20 days. Hopefully, we get a green light from there. I don't know what's going to happen when that happens. I don't know if SpaceX is going to be like, all right, send it, let's go. Or if we're going to not see that, or if they're going to wait a little bit, or if they'll use Booster 4 and ship 20, or they'll use Booster 7 in 23, or 7 in 24. I don't know. I don't know what they're going to do. We'll see. 20 days until the next delay. Yeah. Bran, what's that? I'm suing by paying you. Oh, okay. Thanks, man. I think.
Discovery, go at throttle up.
COPVs even fly when, yeah, the joke went off the screen. Even fly when they aren't supposed to, yeah. Hey, Casper. Continuing the sub from Hokie. Thanks to Hokie for the gifted sub. Right on. All right, guys. Quick mention of this bit of cargo. All right, what do we got here? So, all right, Stephen Marr is a photographer for NASA spaceflight. Around 9 a.m. these start. Yeah, Goalie was trying to show me this. Those things came in. What do we got? Tankerinos. Hey, Pelican. Come on, Pelican. Pelican. Come on, Pelican. Burb. So, I don't know exactly what these are. My money's on methane tanks, but I'm not sure. Those were stored at Boca. One of those remains in Texas. Oh, okay. Well, there you go. Okay. The all-knowing Thomas has spoken. Okay. Okay, I think that's everything. Now it's time for Tuesday Charkovs with Taradra. Tuesday for After Hours, I'm going to play some Tarkov with Taradra. Now, if you're not into that, that's totally cool. I will see you guys tomorrow. I think I'm going to play Kerbal and Summer Car tomorrow. So Kerbal, Space News, and then Summer Car. I have an idea for a plane build, if you guys are up for it. Night, Jim. We do have a SpaceX launch tomorrow. Oh, yes, don't forget, there's a SpaceX launch in the morning. It is... what time is it? What time is that at? 8:45. I don't have a penciled in day, whether it's kind of when I feel like it. So we can pencil it in for Thursday if you want. Yeah. Okay. Very early. Yeah. Okay, Starlink launch at 8:45. If you're seeing me off tonight, I'll probably be on around 8:30. Oh, the plane that I wanted to build. Somebody actually showed me something that ended up being exactly like what I was describing the other day. But mine isn't going to work exactly like this, but something like that. Yeah. We could do that, Bran, yeah. There are 2 opportunities for tomorrow at launch, 8:45 and 10:04. Yeah. I have an idea. For a plane. For a heavy cargo plane. Yeah. And I need to kind of... I'm going to make it... We're going to incorporate it small scale first. But I have an idea for a plane, and I think you guys might like it. I had an idea. So, like, remember the K-90? The K-90 was a good idea. We made a plane that could fly pretty much anywhere, right? We made a plane that could fly pretty much anywhere, and... it could land in water, and then it was amphibious. Think like, yeah, that. But it would be really nice if I didn't have to do a seaplane landing with that thing, and it would be really nice if we could just do like land it like VTOL. Yeah, that would be really cool. It'd be a really cool capability to have. Yeah, I think we should do that. Yeah. Yeah, I think we should do that. I think that's a good idea. So, yeah, that's what we're going to do. Yeah, we'll do it tomorrow. Should be fun. An Osprey on steroids. Kinda, Dead Scum, mix an Osprey and an SB-1. Yeah, kinda like that. Yeah. Yeah. I'll have to see if it works in KSP. It might. It's possible. It should be able to be done. I need to take elements from the SB1, elements from the V22, and possibly maybe even the V280. But I have an idea, and it should work. What's an SB1? Fun fact, I applied to be an Osprey software engineer, even got an interview, but never got the call back. Okay, that's neat. You just want a flying aircraft carrier, admit it. No, not really. Not really. I still really want to know what happened at 1049. Was last seen in Port of Long Beach in September of last year after its 10th mission. Yeah, maybe they took it apart, Thomas. Who knows? Anyway, let me go ping Taradra. Let's see what we got. You alive. So I'm going to flip us over to